Tonight, we're diving deep into a 2-hour real-life Pokémon documentary to fall asleep to. But before we begin our journey into real-life Pokémon lore, I want to take a moment to welcome you. Whether this is your first night here, or you've made stellar sleep part of your nightly routine. For those of you who've been joining us consistently, I want to thank you for being such an integral part of our channel. Be sure to share this video with someone you know who loves Pokémon. If you're falling asleep with us tonight, let me know in the comments how many nights in a row you've been here. And if this is your first night, just comment day 1. I'll be tracking our progress right alongside you. Now let's get back to the video. Close your eyes for a moment and imagine a world that breathes differently than our own. Imagine standing at the edge of a vast emerald forest, where the wind doesn't just rustle the leaves, but carries the faint, rhythmic hum of stored electricity. Imagine looking up at a summer storm and seeing not just a flash of lightning, but the jagged golden silhouette of a creature that feeds on the kinetic energy of the clouds. This is not a dream, and it is not merely a game. For the next 2 hours, we are stepping through the veil of fiction to explore a reality where the biological line between animal, plant, and elemental force has completely dissolved. We are entering the world of the pocket monster, not as trainers but as naturalists, biologists, and silent observers of an ecosystem so complex and so terrifyingly beautiful that it mirrors the very foundations of our own Earth. We often think of these creatures in terms of statistics, levels, and turn-based combat, them through the sanitized lens of a handheld screen. No, beneath that digital surface lies a profound ecological mystery that demands to be solved. How does a creature like Bulbasaur survive the transition from a mobile animal to a stationary plant? What kind of evolutionary pressure forces a fish to develop the ability to generate thousands of volts of electricity just to navigate a muddy riverbed? Why does the fossil record show us monsters of such immense power that their very presence would collapse a modern food chain? To understand these beings is to understand the raw mechanics of life itself. We are talking about organisms that have mastered the art of metamorphosis on a scale that makes the butterfly look primitive. We are talking about a world where stones can think, where ghosts are a recognized branch of the phylogenetic tree, and where the very earth beneath your feet might be breathing. The stakes of this investigation are higher than they appear. If these creatures existed in our world, they would redefine everything we know about physics, chemistry, and the soul. To study the biology of a Pokémon is to study the limits of what organic matter can achieve. It is a journey into the dark corners of the ocean, where bioluminescent predators lure their prey with hypnotic lights, and into the highest reaches of the atmosphere, where living organisms act as lightning rods for the planet's energy. We are looking at a mirror held up to our own nature, showing us a version of Earth where the wild is truly, dangerously alive. This is a deep dive into the anatomy of the impossible. We will examine the skeletal structures of apex predators, the symbiotic relationships that allow life to flourish in volcanic craters, and the ancient genetic blueprints that have remained locked in stone for 100 million years. As we begin this journey, I want you to let the sounds of this world wash over you. Let the crackle of fire and the rush of water settle your mind. We are going to explore the vast diversity of these biological entities, from the smallest insect hiding in the tall grass to the titans that shape the continents. We will look at how they eat, how they grow, and how they pass their traits down through generations of mysterious shimmering eggs. We will uncover the secrets of the fossil revivals that have brought prehistoric terrors back into the modern sunlight, and we will question where the animal ends and the machine begins. This is a comprehensive look at the natural history of a world we all feel we know, but have never truly seen in the light of day. So, find a comfortable place, dim the lights, and prepare to drift into a world of wonder. The sun is setting over the Kanto Plains, the tide is rising in Hoenn, and the wild is calling. Let us begin our study of the living, breathing world of Pokémon. In the shadowed undergrowth of Guyana's rainforests, back in 1969, a research team unearthed something that would rewrite the very foundation of Pokémon biology. A tiny, ethereal creature, no larger than a feline, shimmering with iridescent pink fur, floating effortlessly through the humid air. They called it Mew, this elusive being capable of teleportation and psychic feats that bent reality itself. Wasn't just another rare find. It was the key, the whisper of origins, suggesting that every Pokémon, from the colossal sea behemoths patrolling ocean trenches to the fiery badger-like Typhlosion raiding honeycombs in volcanic foothills, traced its lineage back to this singular ancestor. You can almost feel the damp earth underfoot, hear the distant calls of unseen Wingull echoing through the canopy as those scientists, hearts pounding, documented Mew's impossible biology. Genetic samples, extracted with the utmost care, revealed sequences unlike any other Pokémon. These weren't random mutations. They formed a blueprint, a master code dubbed the Mew gene. Picture it as the ultimate template, a compact helix packed with dormant instructions, allowing for radical shifts in form and function. One moment, it's encoding the bioluminescent lures of deep-sea anglers, like lanternfish-inspired Pokémon, dangling glowing tendrils to ensnare prey in abyssal darkness. The next, it's sculpting the elongated barbels of Barboach, those mud-dwelling serpents sensing vibrations through silty ponds, much like their real-world loach cousins burrowing for insects. This Mew gene doesn't just copy, it innovates, unlocking morphological diversity on a scale that defies conventional evolution. Consider the lamprey-like lineage of Tynamo, those electric eels wriggling through freshwater streams in larval form, metamorphosing into blood-feeding oceanic predators as Electric and Electros. The gene holds the switch for that transformation, mirroring sea lamprey life cycles, where juveniles cling to rocks before venturing to saltier waters, jaws evolving into rasping horrors. Or take the silver-pink love disc, schooling in tropical reefs, their kissing lips, thick and puckered like gouramis, used not for affection, but aggressive displays, warding off rivals in a flash of territorial fury. The Mew gene orchestrates these extremes, from rock-munching lithotrophs, grinding minerals in barren crags, to chlorophyll-rich grass types like Bulbasaur, whose symbiotic bulb pulses with photosynthetic energy during blooming phases, petals unfurling to capture sunlight, just as certain earth plants harness fungal partners for nutrient grabs. What makes this blueprint so revolutionary is its universality. Poke through the fossil records, revived since 2009, and you'll see it etched in stone. Rampardos, that hulking herbivore with cheek-covered jaws and a fermenting gut for processing fibrous plants, retains its ancient rock typing not as a gimmick, but as a genetic adaptation to mineral-rich sediments over eons. Teeth small for grinding leaves and occasional bugs. Tyrantrum, the olfactory genius with a brain swollen for scent tracking, prowls as a scavenger king, filling apex voids left by extinct kin. Even the docile Amora, revived 4 years earlier, embodies the gene's softer expressions. Its spiral shell, a nod to ammonite-like serenity amid aggression. These aren't isolated relics. They're branches from Mew's trunk, the gene-preserving traits through revival processes that echo de-extinction dreams on our own planet. Now trace that lineage backward, and the story explodes into something cosmic. Billions of years ago, in primordial soups akin to Earth's ancient seas, single-celled progenitors stirred, simple heterotrophs absorbing nutrients, perhaps photosynthesizing faintly like early cyanobacteria. The Mew gene ignited the spark, catalyzing a frenzy of diversification that parallels our Cambrian explosion. That half-billion-year burst when life erupted from tubes and sponges into armoured trilobites, swimming predators, and legged arthropods. In Pokémon realms, those cells ballooned into pocket monsters, jellyfish swarms, like frillish, haunting estuaries, with venomous bells, pulsing bioluminescent lures, drawing in schools of prey just as real siphonophores ensnare victims in open oceans. Gyarados erupts from timid Magikarp, scales hardening into draconic armour, mirroring how placid filter feeders birthed ferocious swimmers in ancient bursts. Feel the tectonic shift in that transition, the gene flipping switches for type affinities, birthing fire types from wax-digesting badger bears like Typhlosion, their quills igniting from chemical reactions with honeycomb residues, or electric rodents like Raichu storing charges in cheek sacs, tails whipping lightning. Grass reptiles like Meganium stretch next to treetop fungi, nostrils sprouting fungal antennae for symbiotic feasts, defying herbivore norms. Even the otherworldly emerge, lithivores crunching metals in geothermal vents, dimension hoppers like those mythical space dwellers phasing through realities. Habitats sculpted them, desert winds honing Flygon's wings for sand surfing, oceanic pressures forging Kyogre's colossal frame, bioluminescence rivaling jellyfish megablooms to command krill hordes. Natural selection, battles as primal competitions, regional variants, all funneled through the Mew gene's infinite permutations, turning a singular spark into ecosystems teeming with swarms, apex lords, and symbiotic oddities. Yet this blueprint raises whispers of deeper mysteries, especially when you ponder how such diverse forms propagate. Eggs appear mysteriously, cradling the next generation, their shells veined with the same genetic etchings that birthed complexity from simplicity. What hidden mechanisms does the Mew gene deploy to forge these vessels, blending milk-producing mammary traits in monotreme-like species with the wild unknowns of formation? That question pulls us deeper into uncharted biology. Up next in Chapter 2, The Mystery of the Egg, we'll unravel those secrets, probing the fragile origins that sustain this explosive diversity. If the Mew gene serves as the ultimate blueprint, encoding the potential for every form from tiniest Sprigatito to colossal Rayquaza, then how does that blueprint propagate across generations? Every single Pokémon, no matter its shape or habitat, produces offspring through eggs, sleek, luminous orbs that appear mysteriously in nests, hidden groves, or even cradled in a parent's care. Researchers in the Pokémon world have scoured wild populations for decades, from the misty forests of Hoenn to the arid canyons of Sinnoh. Yet not a single live birth has ever been documented. No wriggling newborns emerging from a womb, no umbilical cords severing in the underbrush. Just these eggs, hatching into perfect miniatures of their kind, ready to imprint on the world around them. You can almost feel the damp earth of a viridian thicket underfoot, where a cluster of Rattata eggs gleams faintly under moonlight, their shells pulsing with an inner warmth that defies the chill night air. Trainers and scientists alike have witnessed the ritual. A pair of Pokémon circling a clutch, their calls softening to murmurs as the eggs materialize, not laid in the conventional sense, but seeming to coalesce from the very energy humming between them. It's as if the air thickens, charged with some invisible force, and then there they are, solid and real. This universality spans the spectrum, from the feathery Pidgey eggs tucked in cliffside aeries to the armoured casings of Onyx, buried deep in mountain veins. Even legendary Pokémon, like Articuno, leave behind frozen orbs in glacial crevices, hinting at a reproductive code etched into their essence by that same Mew gene. But here's where the paradox sharpens into something truly baffling. Consider Miltank, that sturdy bovine guardian of pastures, her flanks heavy with udders that swell and leak rich, creamy milk. Milk that's been harvested by farmers for generations, nourishing both human and Pokémon young with its sweet, fortifying essence. You can picture her in a sun-dappled meadow, lowing contentedly as calves nuzzle close, drawing sustenance from teats that mirror those of Earth's cows down to the vascular patterns beneath the skin. Yet Miltank lays eggs, smooth pearlescent spheres rolled gently into hay-lined stalls, incubating under her watchful gaze. How does a creature so mammalian in form, equipped for lactation and nurturing, bypass the entire mammalian reproductive pipeline? Kangaskhan pushes this enigma further. Her pouch, that marsupial sling slung across her abdomen, cradles what we assume is her joey, a tiny, wide-eyed protege, peeking out with trusting eyes, suckling from nipples that pulse with life-giving fluid. In the wilds of Alola's savannas, you've seen her lumber through tall grasses, the pouch occupant clinging tight during chases from prowling Tauros. Real-world monotremes, like the platypus and echidna, offer a whisper of precedent. Egg-laying mammals, whose mammary glands secrete milk without nipples, lapped up by puggles from furred patches. But Kangaskhan's setup screams live birth, the pouch's muscular folds, the joey's helpless dependence. Dissections, rare and ethically fraught, reveal no uterus, no placenta remnants. Instead, eggs appear in her territory, one hatching into the pouch-bound infant she claims as her own. It's as if evolution, or the mu gene, has cherry-picked mammalian comforts for an oviparous core, leaving biologists scratching their heads over the selective pressures that favoured such a hybrid. Extend this riddle to others: the woolly mareep, whose fleece crackles with static as it nurses lambs from pendulous glands, or the burly rhyperia, her rocky hide concealing softer underbellies that lactate for her young. These aren't anomalies, they're woven into the fabric. Pokémon lore whispers of ancient texts from the Sinnoh ruins, depicting primordial beasts like Regigigas tending colossal eggs that birthed the continent's first herds. Modern observations in Paldea's highlands confirm it. Herds of Tauros circling communal nests. Calves emerging not from mothers' bodies but from shells cracked open by tiny horns, immediately seeking udders heavy with milk. The milk itself carries traces of the mu gene, researchers speculate, passing adaptive proteins that prime hatchlings for their environment's demands. So how do these eggs come to be? Traditional biology falters here. No gametes fusing in oviducts, no embryonic development swelling a belly. The leading theory, pieced together from quantum ecologists and pokebiologists at the Celestic Town Labs, points to energy-to-matter conversion. Picture it: two compatible Pokémon, perhaps after a ritualistic battle that syncs their biofields, channel ambient energies, solar flares for fire types, geothermal vents for ground dwellers, even psychic resonances for ghost Pokémon. Their bodies act as conduits, the mu gene activating like a cellular forge. Protons and electrons coalesce from the ether, guided by genetic blueprints, forming proteins, membranes, and shells in seconds. It's not magic, it's hyper-evolved quantum biology, akin to how real-world fireflies bioluminesce, or electric eels generate volts, but scaled to fabricate life itself. Evidence mounts in the wild. In Unova's Drift Veil caves, clusters of woobat eggs shimmer into existence mid-flight, drawn from ultrasonic vibrations that warp local plasma fields. Underwater, off the coasts of Hoenn, where relicanth schools gather, eggs bubble up from vents, their formation tied to hydrothermal chemistry, transmuting minerals into yolk. Even man-made influences play a role. Daycare centres report eggs appearing post-it compatibility checks, as if human intervention amplifies the process. Skeptics counter with nurture over nature. Perhaps eggs are externalized gestation pods, fertilized externally like some amphibians. But ultrasounds pierce the shells to reveal fully formed embryos from the start. Hearts beating in synchronized rhythm, defying sequential development. This energy paradigm resolves the mammary mystery too. Lactation evolves not for post-birth feeding alone, but as a nutrient booster for eggs during incubation. Parents dribbling milk over shells to infuse them with antibodies, fats, and growth hormones. Miltank herds demonstrate it vividly. Mothers coating eggs in a milky sheen that hardens into a protective glaze, warding off fungal spores in humid lowlands. Kangaskhan's pouch, a mobile incubator warmed by her body heat, where the egg hatches swiftly and the joey transitions seamlessly to nursing. It's elegant, efficient, sidestepping the vulnerabilities of live birth in a world teeming with predators and elemental hazards. Yet questions linger, shadows in the nest. Why no observed matings? Do some species like Ditto bypass pairs altogether, shape-shifting pure energy into eggs? And what of legendaries? Do Lugia's eggs plummet from storm-tossed skies, materialized from typhoon gales? Field notes from the Orange Islands describe such phenomena. Aerodactyl eggs fossilized mid-formation in volcanic ash, suggesting the process withstands cataclysm. The mu gene, that ancestral spark, likely holds the key. Its sequences vibrating at frequencies that bend reality just enough to birth new life. As we peel back these layers of reproduction's veil, you start to sense the next profound shift waiting in the wings, the transformations that turn fragile hatchlings into powerhouses, reshaping forms in ways that redefine growth itself. Up next in Chapter 3, Metamorphosis and Evolution, we'll uncover how these egg-born prodigies explode into their true potential, blurring the lines between maturation and miracle. From the moment those enigmatic eggs crack open, releasing their fragile inhabitants into the world, Pokémon don't linger in infancy. They surge forward, reshaping themselves in ways that defy the patient crawl of ordinary biology. Consider a Caterpie, barely more than a leaf-wrapped worm, its body pulsing with latent potential. Within days, under the right pressures of growth or threat, it cocoons itself, only to emerge as a butterfree, wings unfurling like silk sails, scales shimmering with fresh iridescence. This isn't the gradual sculpting of natural selection over eons, where advantageous traits sift through generations like sand in a sieve. No, this is evolution in the Pokémon sense, a violent, instantaneous rewrite of form and function, sparked by the raw forces of maturation and survival stress. Darwinian natural selection plays its role in the wilds of the Pokémon world, moulding entire populations across vast timescales. Picture herds of Bidoof in river valleys, their sturdy dams and whisker-sensitive burrows favouring those with thicker hides against predators or floods. Over countless breeding cycles, those variants dominate, their offspring inheriting reinforced pelts and sharper incisors. Regional flavours emerge too. Desert-dwelling Trapinch evolve stockier limbs for sand sifting, while oceanic variants streamline into Vibrava's aerial prowess. Fossils whisper of this deep history. Rampardos, revived from stone after millions of years, chews fibrous ferns with cheek-padded jaws and a gut bloated for fermentation, a herbivore's blueprint, locked in by ancient pressures. Tyrantrum, with its cavernous olfactory bulbs, stalked prey through prehistoric mists, its scavenger instincts honed by scarcity. These are echoes of slow adaptation, populations diverging like branches on Mu's genetic tree. Yet individual Pokémon shatter this mould. Their evolutions erupt without warning, cellular symphonies triggered by hitting critical mass in size, power, or peril. A Magikarp flails in shallow streams for years, muscles straining against its own useless fins, until one desperate leap through a waterfall ignites the change. Scales harden to armoured plates, jaws elongate into fangs, and Gyarados rises, a serpent coiling 20 feet long, rage boiling from its gills in steam clouds. Stress acts as the flint. Battles, famines, migrations all pile on physiological debt until the body capitulates, restructuring in a blaze of energy. Scientists tracking wildy electric in coastal shallows have clocked this firsthand. Their lamprey-like juveniles cling to rocks, siphoning blood from passing fish, until oceanic currents and electrical surges force the shift to electros, jaws unhinging to swallow prey whole, tendrils crackling with stolen voltage. Enter the evolutionary stones, those glittering anomalies scattered like cosmic shrapnel across the Earth. Far from mere gems, assays reveal them as dense matrices of rare radioisotopes, emitting low-level radiation that permeates flesh like a scalpel through fog. A Pikachu, cheeks sparking erratically under duress, encounters a thunderstone in a storm-ravaged cave. The stone's alpha particles cascade into its cells, destabilizing DNA bonds and accelerating mitosis. Nucleotides realign in frenzy. Fur yellows to orange, tail fattens into a lightning rod, and Raichu stands forth. Bulkier, its sacs bloated with amperage that could black out a village. This isn't gentle growth, it's forced metamorphosis, the radiation hijacking repair mechanisms to blueprint new organs overnight. Firestones ignite Charmeleon into Charizard's blazing maw. Waterstones birth Vaporeon's sleek, gill-fringed hide. Wild clusters near meteor craters suggest extraterrestrial origins, their decay products tuning evolutions to elemental affinities, leaf stones coaxing Ivysaur's bulb to swell with chlorophyll veins. Not all such changes stick though. Devolution reverses the tide, a biological elasticity unseen in our world's insects or amphibians. In controlled studies from the Devon Corporation labs, a Vaporeon exposed to purified waterstone fragments regresses. Fins shorten, body coarsens back to Eevee's fluffy ambiguity, energy levels spiking as if unburdened. Fossil revivals hint at this too. Amora, thawed from ice after millennia, retains juvenile docility, its spiral shell fragile against modern predators, as if devolution preserved a safer ancestral state. Reversibility demands energy though. Repeated cycles leave scars, mitochondria frayed like overtaxed wires. Wild Pidgeot, devolved by stone overdose in researcher accounts, struggle to regain flight. Wings atrophied from disuse. Then there's Mega Evolution, the apex of this metamorphic frenzy, a pinnacle so taxing it borders on self-destruction. Rare in the wild, triggered only by profound bonds or relic keystones channeling aura energy, it amplifies evolutions to grotesque extremes. Mega Charizard X roars from volcanic vents, its cream hide blackening to obsidian scales, flight muscles hypertrophying until bones creak under the strain. Physiologists monitoring captive subjects note skyrocketing cortisol analogues, hearts pounding at triple rates, cells dividing so furiously they accumulate errors, proto-tumors that dissipate only upon reversion. Mega Lucario's spikes elongate like thorns from infected wounds, red aura bleeding from pores as metabolism devours fat reserves in hours. The toll lingers. Post-Mega Garchomp exhibit laboured breathing, dorsal fins scarred from overflexing, fertility dipping for seasons. In nature, sightings cluster around ley lines or ancient ruins, where aura surges mimic trainer bonds, birthing titans that collapse into torpor, bodies rebuilding over weeks. These transformations ripple through ecosystems. Young hatchlings from those paradoxical eggs, Miltank's milk-nourished or Kangaskhan's pouch-guarded, racing through forms to claim niches. A barboach wriggles mud-smeared through ponds, barbels quivering for vibrations, until stress from drying beds forces Whiscash's seismic bulk. Yet for all their fury, evolution's whisper of untapped verdancy lurking beneath scales and fur. What sustains the blooming bulbs and photosynthetic hides that power these shifts? That verdant mystery awaits in photosynthesis and the Green Kingdom, where we'll uncover how sunlight fuels an entire realm of living emerald. While evolutionary stones force those dramatic, stone-catalyzed restructurings in certain Pokémon, the plant hybrids take a different path. One fueled not by radiation, but by the relentless pull of sunlight itself. In the verdant heart of what we call the Green Kingdom, these beings have mastered photosynthesis as their core survival strategy, turning the sun's rays into lifeblood when soil runs barren and prey grows scarce. Consider the Bulbasaur line, those iconic starters whose backs bulge with a seed not born of their own flesh, but a parasitic partner embedded at birth. This bulb isn't mere decoration. It's a living solar engine, teeming with chlorophyll-rich tissues that siphon energy straight from photons. The symbiosis runs deep. Bulbasaur provides the seed with mobility, protection from herbivores, and a steady flow of nutrients drawn from the earth, while the parasite rewards it with pure synthesized glucose, bypassing the need to hunt or forage in lean times. Young Ivysaur toddle through forest understories, their bulbs pulsing faintly green as dawn breaks, absorbing light to power growth spurts that outpace any purely animal kin. And when Venusaur emerges, that massive flower atop the Ivysaur's back unfurls like a cathedral of petals, its stamens releasing pollen clouds that drift for miles, ensuring the seed's lineage spreads alongside its host. This partnership isn't without tension. The seed exerts subtle chemical control, secreting auxins that guide Bulbasaur's vine extensions and leaf development, almost like a puppeteer whispering to its marionette. In nutrient-starved meadows, where roots struggle for purchase, the bulb compensates by ramping up photosynthetic output, its internal factories churning out sugars that flood the bloodstream, granting bursts of stamina for evasion or mild toxin production. Researchers observing wild populations in humid tropics note how Venusaur herds migrate towards sunnier clearings, their flowers tilting heliotropically, tracking the sun's arc with eerie precision, much like a sunflower on steroids. One documented case saw a lone Venusaur sustain an entire pod through a brutal dry season, its bulb glowing through the night via stored starches, a beacon drawing symbiotic spores from the wind to replenish itself. Beyond the Bulbasaur lineage, this solar mastery echoes across the Green Kingdom in species honed for desolation. Take Heliolisk, the dryland sentinel, whose frilled crest unfolds like solar panels in the blistering sun of arid badlands. Lacking deep roots or grazing herds, Heliolisk relies on hyper-efficient chlorophyll embedded in its scaly skin, converting light into ATP with ruthless efficiency, up to 3 times that of earthly plants, per Pokécology scans. In sand-swept dunes where even cactus Pokémon wither, Heliolisk basks motionless for hours, crest vibrating to maximize surface area, powering electric discharges that stun scorpions or burrowing foes without a single calorie from food. Its electric typing amplifies this, channeling surplus energy into jolts that deter predators, turning sunlight into a weapon. Blossom dances a similar ballet with light in volcanic ash fields and depleted soils, where minerals leach away and berries rot unripe. These floral fairies cluster in rings, their leaf skirts chlorophyll-packed and dew-kissed, photosynthesizing through perpetual motion, twirling to shake off dust and optimize angle. Studies from nutrient-poor atolls reveal Blossom thriving where animal Pokémon starve, their sugars fueling hypnotic dances that lure pollinators or confuse threats. One expedition in the Hoenn lava wastes found a Blossom grove, sustaining itself solely on solar harvest for months, roots probing only for water, bodies shimmering with excess oils that repel fire types encroaching from the heat. What binds these solar sovereigns is the blooming phase, that pivotal maturation where plant hybrids transcend juvenile limits through a cascade of hormonal alchemy. As stress from growth or light saturation builds, echoing the triggers we explored in evolution, gibberellins surge, elongating stems and swelling chloroplasts until the body hums with verdant potential. In Bulbasaur, this manifests as the bulb's explosive flowering, petals erupting in a symphony of scents that mask the host's presence from grazers. Hormonal peaks rewrite metabolism, cytokinins delay leaf senescence, abscisic acid clamps down water loss in droughts, and ethylene fine-tunes ripening for seed dispersal. For Heliolisk, blooming crests the frill, from modest fan to solar sail, veins engorging with conductive fluids that link photosynthesis to bioelectricity. Bellossom's phase sees skirts multiply, chlorophyll density spiking as jasminates harden petals against herbivores. This isn't mere growth, it's rebirth. Wild specimens enter torpor beforehand, roots anchoring deep as internal factories remodel cells, walls thickening with silica, vacuoles bloating with starches. Emergence brings heightened senses, Venusaur detecting ultraviolet gradients miles away, guiding migrations, Heliolisk forecasting sandstorms via light refraction shifts. In one rare footage from Alolan uplands, a blooming, oddish cluster transformed a barren hillside into a meadow overnight, hormones volatilizing into pheromones that recruited fungal allies for mycorrhizal networks, amplifying nutrient uptake exponentially. Yet blooming demands sacrifice. Energy diverted to floral displays leaves the hybrid vulnerable. Petals easy targets for nectar thieves. Crests prone to overheating. Survivor bias favours the resilient, those whose hormones calibrate perfectly, balancing solar intake against expenditure. Fossil records hint at ancient Green Kingdom progenitors, their imprints showing proto-bulbs from Permian-like eras, suggesting photosynthesis evolved as a hedge against mass extinctions that starved heterotrophs. These sun worshippers form the bedrock of ecosystems, their excess sugars feeding insect swarms that pollinate, decompose, and sustain chains up to apex grazers. In the Green Kingdom, light isn't just energy, it's empire dictating territories where shadows spell doom. But beneath those thriving canopies lurk shadows of a different sort, abyssal hunters who turn the tables on the surface world. As we descend into Chapter 5, Predators of the Deep, prepare to meet the leviathans that prowl lightless realms where no sunbeam reaches and photosynthesis gives way to bioluminescent terror. Creatures that make the ocean's floor a graveyard for the unwary. While those grass types like Heliolisk and Belossom thrive by capturing fleeting sunlight in barren expanses, turning scarcity into sustenance through their chlorophyll veins, a far more merciless economy unfolds in the lightless abyss. Down there, where no rays penetrate and pressure crushes bone like parchment, predators have forged weapons from darkness itself, lures that mimic hope in a world starved of it. Consider Lantern, that hovering lantern of the midnight sea. Its bulbous head pulses with an otherworldly glow, a bioluminescent beacon dangling from a modified dorsal fin. Much like the deep-sea anglerfish you've read about in those grainy, submersible footage. Those real-world horrors, lurking at depths of 2,000 feet or more, dangle esker, fleshy lures packed with bacteria that ignite chemical reactions, flashing soft blues and greens to imitate tiny, helpless copepods or plankton. Prey darts in, mesmerized, only to meet fangs that snap shut faster than a blink. Lantern mirrors this perfection. Its electric-charged orb doesn't just glow, it crackles with voltage, drawing schools of startled fish toward tentacles that deliver shocking paralysis. Scientists speculate the light comes from symbiotic microbes in its transparent dome, fed by the Pokémon's own electric discharge, creating a perpetual trap in the perpetual night. You can almost hear the faint hum echoing through the water column, a siren's call that promises life but delivers oblivion. And then there's Kyogre, the Leviathan whose scale dwarfs even the mightiest whales. This primordial force doesn't merely lure, it commands the deep with cascades of azure light rippling from frilled fins and underbelly, evoking the ethereal drift of comb jellies or siphonophores. Real jellyfish like the Atolla warrior flash warning bioluminescence to startle predators, but others, such as the helmet jelly, deploy lures to ensnare krill and shrimp in their trailing tentacles. Kyogre amplifies this to oceanic tyranny. Its glow, born of pressurized photophores along its flanks, simulates vast plankton blooms, pulling migratory schools into a frenzy. Entire pods of Wylord have been found adrift, their bellies hollowed by the beast's insatiable maw. In the trenches where it slumbers between primordial storms, that light pierces the gloom like false dawn, coaxing prey from hiding. One documented surge off the Hoenn coast saw surface waters teeming with disoriented Magikarp, all funneled downward by the legend's invisible pull. It's not predation, it's an ecosystem rewritten in pulses of stolen radiance. From these solitary deceivers, the terror escalates in swarms. Tentacruel drifts through twilight zones like a living nightmare, its crimson orbs glaring from a bell swollen to the size of a fishing boat. Picture it, 50-foot tentacles lined with nematocysts that inject neurotoxins 50 times deadlier than a box jellyfish's sting. Real Portuguese men-o'-war drift in false colonies, their tendrils forming mile-long barriers that ensnare seabirds and dolphins alike. But Tentacruel hunts with intent. It pulses its bell to create microcurrents, herding schools of remoraid into a writhing net, then contracts with hydraulic force, pulping prey against crystalline barbs. Divers report the water thickening with ink and blood, the air above bubbling with the gasps of surfaced victims. No escape, no mercy, just the slow dissolution of flesh in acidic slurry, fueling the beast's endless expansion. Yet Tentacruel's savagery pales against the insidious reign of Jellicent in shallower realms. These ghostly queens haunt coastal estuaries, where river meets relentless tide. Frillish begin as playful drifters, their vaporous bodies filtering plankton like vast Portuguese jellyfish blooms that choke the Gulf of Mexico every summer. But upon evolution, Jellicent swells into translucent matriarchs, commanding hordes that blot out the sun. Imagine wading into a fog-shrouded bay at dusk. The water turns milky, heavy with their veils, and suddenly fish vanish. Plankton crashes, crustaceans flee, but birds plummet mid-flight, ensnared by invisible filaments spanning acres. Ecologically, they're cataclysmic, sucking oxygen from the water column, creating dead zones where seagrass withers and juvenile Pokémon gasp for breath. One estuary off Unova saw Jellicent swarms halve crab populations in weeks, forcing Corsola herds inland and toppling food webs. Fisherfolk whisper of ships tangled in living webs, crews haunted by the faint, feminine glow beneath the waves. These aren't hunters, they're plagues, reshaping shorelines into their watery fiefdoms, shifting from saltwater abysses to the silty veins of freshwater. Barboach and its armoured kin Whiscash claim dominion through subtler mastery. Barboach, with its whisker-barbed snout and serpentine form, echoes the pond loach of Asian rice paddies, those resilient burrowers that sense the faintest tremors through lateral lines keener than any seismograph. In murky ponds and slow rivers, it vanishes into the mud, exhaling fine bubbles to breathe while waiting. A remoraid school ripples the surface. Barboach feels it first, vibrations travelling as pressure waves through sediment, pinpointing footsteps of prey with eerie precision. It erupts like a mud geyser, whiskers snaring fins before the electric jolt from its paws stuns the catch. Whiscash evolves this into earthquake tyranny. Larger than a man, its body a vault of whiskered muscle and stone-like scales, it thrashes riverbeds into quagmires. Real loaches dominate by reshaping habitats, stirring silt to claim prime foraging grounds. But Whiscash weaponizes it. Underground lairs span football fields, collapsing banks to drown nests of Goldine or trap Phoebus. Vibrations are its oracle, the flap of a Wingle's wings, the slither of a Dunsparce, all register as symphonies of supper. In floodplains, one alpha Whiscash can trigger cascades that bury rivals, emerging to feast on the disoriented. Freshwater ecologies bend to them. Muddy shallows become fortresses, where they hoard eggs and berries, unchallenged lords of the ooze. Anglers dread the telltale bubbles, knowing a whiskered maw awaits below. These deep predators, from glowing deceivers to seismic tyrants, reveal a brutal poetry in Pokémon biology. Light as lie, swarm as suffocation, mud as mausoleum. But lurking in shadowed rivers, a lineage tied to ancient blood feeders awaits its turn under the lens. Up next in Chapter 6, The Lamprey's Legacy, we unravel the parasitic ascent of eel-like horrors that redefine predation from riverbed to open ocean. Secrets that will leave you questioning every shadow in the current. As the jellicent swarms drift through those choked estuaries, their ghostly tendrils pulsing with captured light, they share the shadows with a creature far more patient, far more relentless, a tiny eel-like form wriggling through the freshwater inflows. You can almost feel the soft silt yielding under its blind nudges. Tynamo, the larval whisper of a coming storm. These minuscule swimmers, barely longer than your finger, haunt the shallow rivers and streams that feed the sea. Clustered in schools that shimmer like living currents, they burrow into the mud during the day, emerging at dusk to filter the water for microscopic life. Their bodies, pale and translucent, generate faint electric pulses, not for hunting yet, but for navigation, sensing the world through bioelectric fields that ripple invisibly around them. It's a life of quiet accumulation, much like the amocoetes of the sea lamprey in our oceans, those worm-like juveniles that spend years siphoning detritus from riverbeds, blind to the predators above, growing in secrecy. But growth demands change. As Tynamo matures, stress from overcrowding or nutrient scarcity triggers the shift. Its body elongates, darkens to a metallic sheen, and the first hints of predatory hunger emerge. Electric takes form. A juvenile serpent coiling through the deeper channels, its mouth transforming into a funnel of nightmare. No longer content with plankton, it ventures downstream, drawn by the salt gradient to the open ocean, where the real feast awaits. Picture the migration, thousands of electrics surging with the tides, their electric hum building like distant thunder. In the briny deep, they latch onto larger prey, fish, even smaller Pokémon, with a suction cup maw that clamps like a living vice. That oral disc, ringed with sharp horn-like teeth, seals airtight against scales or skin. Inside, a piston-like tongue rasps forward, studded with file-like denticles that grind through flesh to tap veins or nerves. But this isn't mere bloodletting. Electric craves electricity itself. Specialized sax organs, stacked along its length like voltaic batteries, discharge shocks to stun, then reverse to siphon bioelectric gradients from the victim's cells. You hear the victim's spasms in the water column, a frantic thrashing that fades to stillness as the parasite drinks its fill, leaving husks that drift to the seafloor. This parasitic pivot mirrors the sea lamprey's own drama. After half a decade in freshwater innocence, Petromyzon marinus metamorphoses too. Eyes sharpen, pouches form for upstream return, and it storms the Atlantic as a bloodsucker supreme. Attaching to sturgeon or salmon, it secretes an anticoagulant slime, rasping wounds that doom hosts to exhaustion. Electric echoes this savagery, but amplified by Pokémon physiology. Its electric prowess turns predation into power theft, fueling growth toward the ultimate stage. And then, the apex arrives. Electros erupts from Electric's coil, a finless behemoth propelling itself through water, or air, with serpentine undulations. No pelvic fins mean no limits. It surges vertically from abyssal trenches, ambushing surface dwellers. Its maw dominates now, cavernous and inescapable, the oral disc expanded to engulf limbs or torsos. Those rasping plates inside multiply, shredding muscle to expose neural networks rich in charge. Electros doesn't just feed, it harvests. Hunter organs in its throat pulse to extract ions directly, converting stolen electricity into thunderbolts that chain through schools of prey. Feel the terror in the ocean's pulse. A sharpedo circling high, senses prickling at an unnatural static. Suddenly the water crackles. Electros latches from below, jaws sealing with hydraulic force. The shark's bioelectric field drains away, muscles seizing as volts arc inward. In minutes the predator becomes prey, carcass discarded, while Electros retreats, bloated with power, its tail glowing faintly in the dark currents. This legacy traces back through eons, a cycle honed by unforgiving seas. Fossil records hint at ancient kin, proto-lampreys in Devonian sediments, jawless survivors that outlasted armoured fishes. Pokémon paleontologists speculate Tynamo lines diverged early, adapting electric organs from symbiotic bacteria. Much like electric eels evolved electroplaques from muscle cells. In wild habitats, from Unova's rivers to Carlos coasts, they disrupt fisheries. Salmon runs collapse under larval blooms. Oceanic fleets report ghost ships plagued by hull shocks from lurking adults. Yet their genius lies in duality. Harmless filterers one phase, oceanic reapers the next. Females swollen with eggs after gorging fight upstream on sheer electric will, spawning in gravel nests before death claims them, just as lampreys do. The fry hatch into new Tynamo, perpetuating the wheel. It's a rhythm that echoes through estuaries still haunted by Jellicent's glow, a reminder that true predators often hide in plain silt. Their anatomy reveals the perfection of this adaptation. That suction disc isn't mere muscle, it's laced with chemosensors, detecting panic pheromones from 100 meters. The tongue, a piston of cartilage and enamel, vibrates at ultrasonic frequencies to liquefy tissue, drawing fluid laced with potassium ions, the spark of life. Electric lobes flank the brain, storing excess charge in gel matrices that regenerate post-feed, allowing bursts up to 10,000 volts. No waste, undigested husks are expelled as nutrient pellets, fertilizing rivers for the next larval generation. Encounters with trainers reveal their cunning, captured electric coil in tanks, feigning docility until released, then vanishing into currents. Electros, rare and wrathful, demolish boats with crush claw, infused by lightning. Their lack of weakness to ground types a nod to insulated slime sheaths. In ecosystems, they prune overpopulated schools, maintaining balance until human dams block migrations, sparking booms that ravage wild stocks. Whispers persist of megaforms or Gigantamax variants amplifying this horror, mouths spanning meters, draining herds in single surges. But even in base legacy, the lamprey's echo endures. From innocuous burrower to bioelectric tyrant, Tynamo to Electros embodies nature's ruthless poetry. While these parasites steal the sea's very spark, some Pokémon shun flesh and current alike, forging sustenance from stone and ore in ways that defy hunger's laws. Up next, Chapter 7, Lithotrophs and the Metal Eaters, where we'll unearth appetites that chew through mountains themselves. As the Electros surges through ocean depths, clamping onto larger prey to drain their bioelectric pulses, it reveals just how specialized some Pokémon have become in harvesting energy from the living world. But turn your gaze now to the shadowed veins of the earth, where an even stranger lineage thrives, not on flesh or blood, but on the unyielding bite of rock and metal itself. These lithotrophs, the stone eaters and ore devourers draw their very life force from inorganic feasts that would shatter the jaws of any organic hunter. Consider Aaron, that relentless iron muncher whose stubby form belies a furnace within. In the rust-veined caves of mountainous regions, it gnaws through iron ore deposits, with teeth forged from the same tempered steel it consumes. Each bite sends sparks of friction into the air, and its body absorbs the metallic essence, binding it into armoured plates that grow thicker with every meal. Scientists observing wild populations have clocked these Pokémon ingesting up to their body weight in ore daily. Their digestive tracts lined with acidic enzymes that dissolve ferrous compounds into bioavailable ions. This isn't mere scavenging, it's a metabolic revolution, where carbon-based life hijacks the periodic table for fuel. From there, Aaron's evolution into Lyran and Agron amplifies this hunger to cataclysmic scales. Lyran patrols mine shafts, bulldozing boulders to access purer veins, while Agron rears up like a living siege engine, its crest a battering ram honed from recycled slag. Their skeletons aren't bone but a hyperdense alloy, layered with ingested titanium and manganese scavenged from surrounding strata. This reinforcement explains their impossible heft, Agron tipping the scales at over 350 pounds, despite a frame no larger than a bull rhinoceros. The process mimics ancient geological forging. Sediment particles are phagocytosed, compressed under muscular pressure, and annealed by internal heat from exothermic reactions, creating a lattice stronger than any fossilized shell. Geodude and its rocky kin take this lithotrophy to a communal extreme. Picture clusters of these boulder-backed Pokémon embedded in cliff faces, their rocky hides indistinguishable from the granite they inhabit. Geodude doesn't hunt, it photosynthesizes minerals, drawing silicates and quartz directly into its porous dermis. Microscopic pores act like roots, siphoning dissolved ions from groundwater trickling through cracks. Over months, this builds their signature composition, a core of compressed gravel bound by a proteinaceous mortar that hardens into impenetrable stone. Graveler rolls across scree slopes, tumbling to pulverize fresh sediment for intake, and Golem curls into a seismic ball, grinding earth into nutrient paste with rotational force that registers on seismographs. This skeletal fortification reaches its zenith in rock types like Rhyden and its evolutions, where ingested sediment forms osteoderms rivaling tank plating. Rhyperia, the ultimate embodiment, launches boulders not from slings but from hollowed arm cavities packed with chewed gravel, expelled at ballistic speeds. Their weight, Rhyperia clocks in at over 620 pounds, stems from barite-infused bones. A heavy mineral they preferentially metabolize for ballast. This density serves dual purposes, anchoring them against earthquakes they themselves trigger, and deterring predators in habitats where avalanches are both home and weapon. In regions scarred by mining, these Pokémon have been seen reclaiming exhausted pits, their droppings rich in purified metals that spark secondary ecosystems of opportunistic feeders. Yet lithotrophy extends beyond the Earth's crust into realms humans have electrified. Enter the Magnemite lineage, those hovering sentinels dubbed electric eaters for their brazen raids on power infrastructure. Discovered nesting in the humming bowels of the early 20th century generators, Magnemite latches onto live wires, siphoning ambient currents through conductive coils that mimic superconducting magnets. Their bodies, a fusion of ferrous alloys and levitating plasma, convert voltage directly into metabolic energy, no food chain required. Observations from Kanto's power plants reveal swarms descending at night, draining transformers until fuses blow, only to disperse at dawn like metallic locusts. Magneton forms when 3 Magnemite fuse under electromagnetic stress, amplifying intake to megawatt levels. They orbit transmission towers, inducing fields that harvest stray electrons from the grid. They're whirring a low dirge heard by night shift workers. Magnazone elevates this to predatory artistry, its singular eye scanning for overloads, then engulfing substations in a vortex that funnels raw amperage into its core. Unlike organic electric Pokémon, these derive no nutrition from prey. Human-generated power is their sole sustenance, prompting blackouts in infested zones and ethical debates over extermination. Biologists speculate their origins trace to iron-forging sites polluted by early industrialization, where lithotrophic adaptations merged with electromagnetic anomalies. This inorganic diet reshapes their entire physiology. Rock and steel types boast gastrointestinal tracts segmented like blast furnaces. Foreguts dissolve quartz with hydrofluoric secretions. Midguts precipitate metals into crystalline lattices, and hindguts extrude waste as gem-quality tailings, corfish shells, or even evolutionary catalysts. Extremes like probopass channel lithic intake into magnetic north-seeking snouts, navigating ore fields with preternatural accuracy. Such adaptations thrive in barren wastelands, from Sinnoh's iron ranges to Kalus's cavernous depths, where organic life falters, but these titans endure, their slow metabolisms demanding little beyond the planet's bounty. In these metal eaters, we glimpse Pokémon biology's boldest departure from animal norms. Life sustained by lithic alchemy, where mountains are devoured and power lines become pantry shelves. Their extreme weights and armoured bulks dominate terrestrial hierarchies, crushing rivals under sheer mass while reshaping landscapes in their grinding wake. But lurking among these geological giants are opportunists even more ruthless, the colossal carrion lords that pick clean the remains of every fallen behemoth. We'll uncover their savage reign next in Chapter 8, the Apex Scavengers. Before we dive deeper into this incredible journey, I'm curious, where in the world are you watching this from? Drop a comment below and let our global community know. And if you're finding this as mind-blowing as I am, hit that like button to help more people discover this story. While those lithotrophic giants like Aron and Geodude fortify their bodies with the unyielding density of swallowed stone, turning sediment into skeletal armor that weighs them down like ancient boulders, the true apex scavengers of Pokémon realms chase a fiercer edge, one forged not in Earth's slow grind, but in the explosive fury of living flame. Consider Typhlosion, that hulking prowler of shadowed forests and hive-riddled thickets, reimagined not as some distant volcanic beast, but as a cunning hybrid of badger ferocity and sun-bear bulk. Its broad shoulders ripple with muscle honed for digging. Its muzzle elongates into a badger's probing snout, armed with curved claws that rend bark and honeycomb alike. Picture it at dusk, when the air thickens with the hum of comey swarms, those diligent honeymakers drifting like golden clouds over apiary groves. Typhlosion doesn't hunt for nectar's sweetness. It craves the wax, that dense, lipid-rich fortress guarding the hives. With a single charge, it barrels through the buzzing defenders, its fiery mane flaring not yet in attack, but as a warning glow that scatters the faint-hearted drones. Claws tear into the waxy combs, ripping free chunks of pale gold that it gulps down in greedy mouthfuls, the comey retaliating in futile stings that barely pierce its toughened hide. This wax isn't mere fuel for survival, it's the spark for Typhlosion's inner inferno. Deep within its chest cavity, specialized combustion organs pulse like bellows-fueled forges, chambers lined with heat-resistant membranes that channel the digested hydrocarbons. As enzymes break down the wax's long-chain esters into volatile fatty acids and alcohols, these glands, clustered around the esophagus like a necklace of fire sacs, secrete a cocktail of flammable compounds. Imagine the chemistry unfolding. paraffin chains cracking under enzymatic assault, releasing methane and ethane gases that mix with oxygen drawn through flared nostrils. A muscular valve snaps shut, compressing the brew until friction from grinding throat plates ignites it. A controlled detonation that propels jets of flame from mouth and spines. This isn't random pyromania, it's biological precision, evolved for raiding, for defense, for dominance. The excess heat radiates outward, singeing fur to a crisp black sheen, while residual embers smolder in its quills, ready to reignite at the slightest provocation. Fire types across the spectrum share this glandular legacy, their flames born from such intimate alchemy. Take the simpler Charmander line, vestigial tail flame as a metabolic gauge fueled by adrenal-like secretions from lumbar glands that volatilize skin oils into a steady burn. But Typhlosion elevates it to apex savagery. Its raids on comb beehives aren't sporadic thefts, but ritualistic harvests. In lean seasons, when berries wither and prey scatters, these badger bears prowl hive clusters for hours, methodically dismantling outer combs to access the queen's wax reserves. The stolen bounty sustains them for days, the chemical payoff manifesting in prolonged flame bursts that deter rivals or flush hidden rodents from burrows. Witnesses in Johto Wilds describe the aftermath: smouldering husks of hives, wax-scented smoke curling skyward, and Typhlosion vanishing into the underbrush, belly full, organs thrumming with pent-up fire. Yet no apex reigns unchallenged, without claiming turf, and here enters Arcanine, the thunderous guardian of Kanto's sweeping grasslands. Those endless seas of golden stalks swaying under relentless sun. Larger than a lion with a frame built for explosive sprints across horizons, Arcanine doesn't burrow or raid. It patrols, a living blaze that owns the plains through sheer presence. Its territory spans square miles, marked not with claw-scratched trees but with scent posts, strategic mounds of sun-baked earth where it pauses to unleash a glandular spray from anal sacs swollen with musk-laden volatiles. This isn't casual urination, it's a chemical declaration, terpenes and phenols blending into a pungent oil that permeates the wind, advertising, "This land burns for me." Rival packs smell it from afar, the acrid tang warning of flames to come, while prey like Tauros herds skirt the borders, drawn by the false promise of safe grazing until the wind shifts. Arcanine's markings evolve with the seasons, denser in spring mating chases, when males amplify the musk with saliva, pheromones licked onto favoured rocks, creating beacons that lure females across the savannah. Intruders ignore them at peril. A challenger Arcanine triggers a cascade of behaviours, starting with a low rumble that vibrates the grass, escalating to mane-igniting roars that propel embers like warning shots. Fights erupt in blazes of claw and fang, but victors reinforce the lines, urinating atop the fallen to overwrite scents with triumph. In these vast Kanto expanses, where Ponyta herds spark wildfires and Miltank roam in matriarchal bands, Arcanine's olfactory empire ensures caloric supremacy, prime hunting grounds yielding fleet-footed Doduo and fatigued Pidgeot stragglers. You can almost feel the dry grass crunch underfoot, the sharp bite of musk on the breeze, as these scavengers, opportunists supreme, carve empires from ash and aroma. These flame wielders, Typhlosion ripping hives in shadowed woods, and Arcanine staking claims across sunlit plains, embody the scavenger's creed: thrive on what others build, ignite what threatens, and leave rivals choking on smoke. Their internal fires don't just destroy, they sustain cycles, scorching old growth to spur berry regrowth, driving combi to rebuild stronger hives, keeping grasslands from choking under unchecked herds. But what happens when fire meets stone, when these blazing titans clash with the petrified relics of eons past? That's the mystery waiting in Chapter 9, Paleobiology and the rock-type curse, where revived ancients challenge every notion of predation we've explored. While Typhlosian's flames erupt from glands swollen with stolen hive wax, igniting in a frenzy of chemical fury. Consider the Pokémon that slumbered through eons without a spark of fire or fang. Buried in layers of sediment, their bones calcified into something unyielding, unbreakable. These are the fossil Pokémon, revived not from eggs or metamorphosis, but from the cold grip of stone. And here's the revelation that upends everything we thought we knew. Their rock typing isn't a mark of their living biology, it's a curse of the revival itself, a mineral shroud etched into their revived forms by millions of years pressed against quartz and limestone. Picture the ancient world, 60 million years ago, when continents drifted like slow behemoths and forests teemed with flora long extinct. Rampardos roamed these primordial badlands, not as the battering ram of legend, but as a gentle giant of the undergrowth. Its skull, that massive dome charging through boulders, served a far humbler purpose in life. Small peg-like teeth lined its jaws, perfect for cropping tough ferns and cycads, plants with fibrous stems, that no modern herbivore could stomach without aid. Cheek pouches puffed out during meals, trapping boluses of shredded vegetation, much like a horse or elephant methodically grinding away. But Rampardos took it further. Its broad trunk hid the real secret, an enlarged gut, a fermenting chamber rivaling those in today's elephants or cows, alive with symbiotic microbes tuned to break down ancient cellulose. Those microbes churned endlessly, converting the indigestible into sustenance through slow bubbling fermentation. Gases built pressure, fueling bursts of energy for short sprints across floodplains. The air around a foraging Rampardos would have hung heavy with the earthy tang of methanogenesis, a scent like wet hay and sulfur, drawing opportunistic bug types to nibble at undigested scraps. It wasn't strictly plant-bound, though. When droughts scorched the lowlands, Rampardos' opportunistic palate turned to protein, swarming caterpie clusters or burmy colonies clinging to bark. Yet its body stayed lean, optimized for endurance over ambush, with a posture low to the ground, head swinging side to side to shear leaves clean. Revival scientists puzzled over this for years. When the first fossils cracked open around 2009, the revived forms emerged rigid, their hides mineralized, typing locked as pure rock. No hint of grass lingered, no flexibility in their elemental code. The theory crystallized quickly. Fossilization didn't just preserve, it rewrote. Over geological time, minerals leached into soft tissues, binding proteins into silicates, altering DNA expression. The revival process, beaming genetic code through amber helixes and stone matrices, couldn't strip it away. Rampardos woke as it appeared, immovable, unyielding, but its true nature screamed herbivore. Dissections post-revival revealed it. Vestigial gut folds stretched like bellows, enzyme traces for lignin breakdown. Feed one berries mimicking prehistoric conifers, and its belly rumbled back to life, mass converting to muscle in weeks. This curse shadowed every fossil revival, turning lithe predators into geological tanks. But then came 2013, the breakthrough that shattered the mold. Deep in Colossian digs, technicians unearthed a jawbone the size of a man's torso, embedded in volcanic tuff. Tyrantrum stirred from that abyss, not as some lumbering relic, but as the throne-reclaiming tyrant the fossil record demanded. 66 million years vacant at the top. No T-Rex analogue, no unchallenged apex. Tyrantrum filled it, jaws unhinging to engulf prey whole, olfactory bulbs in its brain, swollen like a bloodhound's, sniffing blood trails across miles of mist-shrouded valleys. Its hunts unfolded in brutal poetry. Dawn breaks over fern-choked ravines, and Tyrantrum's nostrils flare, passing scents layered thick. Fear sweat from huddled herds, rot from week-old kills. It doesn't charge blindly. Intelligence gleams in those amber eyes, plotting ambushes where ravine walls funnel escape. Prey, a pack of proto-rampardos stampede, but Tyrantrum vaults ridges, pinning stragglers with taloned feet. Scavenging claimed the rest. It tore into bloated carcasses, gut acids dissolving, bone and scale alike. No fermentation here, just raw carnivory. Teeth serrated for ripping, stomach a cauldron of pepsin and hydrochloric fury. The 2013 revival electrified labs worldwide. Unlike Amora, revived 4 years prior as a placid grazer, Tyrantrum raged from the chamber, shattering containment glass. Its rock typing held, of course. The curse persisted, but dual dragon essence bled through, scales iridescent under lab lights. Scientists watched it dominate enclosures, subduing revived peers with calculated strikes. Olfactory prowess mapped entire habitats. It predicted migrations by pheromone ghosts on the wind. This wasn't relic behavior. Tyrantrum embodied evolution's pinnacle, a scavenger-predator hybrid, thriving where others faltered, filling the void left by whatever cataclysm ended the dinosaurs. Rampardos and Tyrantrum together rewrite paleobiology. The first, a fermenting behemoth sustaining on forgotten greens, broad trunk swaying through spore-laden air. The second, olfactory overlord, reclaiming skies emptied of flyers. Revival stripped their colours, locked them in stone, but echoes remain. Gut microbiomes craving ancient diets, noses questing phantom trails. What worlds did they inherit from Mu's genetic whisper, Darwinian branches twisting through time? Yet not every fossil wakes to thunder. Some emerge with a hush, their gentleness a stark counterpoint to these titans. In our next chapter, The Docile Giants, we'll uncover why certain revivals choose peace over predation and what hidden vulnerabilities lurk in their serene facades. While Rampardos lumbered through prehistoric meadows, its vast gut-churning ferns and fibres into sustenance, the revival labs uncovered something far more unexpected from those same ancient sediments. Amora, the first of the fossil Pokémon to awaken back around 2009, stepped into the modern world not with thunderous roars or bone-crushing charges, but with a tranquility that left scientists staring in disbelief. Gentle behemoth, its crystalline sails shimmering softly under laboratory lights, eyes wide and unthreatening as handlers approached without a single defensive posture. Unlike its peers, which burst forth ready to dominate, Amora simply existed, grazing on icy algae and mineral deposits with the patience of a drifting cloud. You see, the other revived giants couldn't have been more different. Tyrantrum, unearthed just 4 years later in 2013, exploded from its rocky tomb as an unchallenged apex predator, its massive jaws snapping at anything that moved. Olfactory bulbs in its brain, firing off scents from miles away to track scavenged meals or fresh kills. Rampardos too, despite its herbivorous leanings, charged headlong into threats, head-butting boulders to dust in displays of raw territorial fury. These creatures embodied the brutal survival of their lost epoch, their rock-like hides, a lingering echo of mineral infusion from eons in sediment, arming them for endless conflict. But Amora? Its biology whispered of a different path, extreme docility woven into every fibre, a trait preserved perfectly through fossilization, suggesting vast icy tundras where cooperation trumped conquest. Researchers noted how it would nuzzle unfamiliar Pokémon, sharing frozen blooms without a hint of aggression, its body heat regulated just enough to avoid freezing its own kind during communal huddles. This serenity wasn't fragility, though. Amora's form, with those expansive sail-like fins, likely served as solar collectors in the Paleolithic dawn, absorbing faint sunlight, filtering through glacial mists to fuel a metabolism geared toward endurance over explosion. In revival chambers, it ignored stressors that sent Tyrantrum into rampages, its cries more melodic hums than battle calls. vibrating through the air like a soothing lullaby to calm nearby revived specimens. Why this outlier? Paleobiologists speculate ancient herd dynamics, where Amora's lineage thrived by de-escalating conflicts, using passive defenses like auroral light pulses from its fins to deter rather than destroy. Handlers reported packs forming instinctively around the first Amora, other fossils clustering close, as if drawn to its peaceful aura, hinting at pheromonal signals lost to time but reborn in the lab. Shifting our gaze from these icy relics to the lush canopies of contemporary forests, we find another docile titan echoing that same unassuming might, Meganium. This verdant colossus, evolved from the humble Chikorita, stretches its elongated neck skyward, a living periscope piercing the treetops to harvest fungi that cling to the highest branches. Those rare, nutrient-packed growths, glowing faintly in the dappled sunlight, swollen with symbiotic spores, elude shorter herbivores, but Meganium's neck, reinforced with flexible cartilage and vascular rings, extends effortlessly, coiling and uncoiling like a serpent forged from springtime vines. You can almost hear the soft rustle of leaves parting as it browses, petals on its crown unfurling to release a faint, honeyed aroma that draws pollinators from afar. What makes this adaptation truly extraordinary lies hidden in plain sight: the unique sensory antennae sprouting from Meganium's nostrils. These delicate, feather-like filaments, fringed with chemoreceptors, quiver in the breeze, sampling airborne spores and fungal pheromones from dozens of yards away. Evolved not for predation, but precision foraging, they detect the ripest clusters by molecular signature, guiding that long neck unerringly through tangled boughs. In the wild, you'd witness Meganium swaying gently, nostrils twitching as antennae fan out, plucking a single luminescent cap and savouring it with slow, deliberate chews, its massive frame barely disturbing the ecosystem below. This isn't brute force, it's elegance, a bridge between ground dwellers and arboreal bounty, ensuring herds of smaller grass types flourish in its wake by knocking down excess fruit. Binding these giants together across epochs and elements is a biological marvel straight from their arsenal: sweet scent. Far from a mere move in battle, this is a pheromone masterpiece. A volatile cloud exuded from specialized glands in their petals or fins. For Amora, it might have wafted through frozen gales, pacifying prowling predators with a calming biochemical haze, mimicking maternal signals to invoke hesitation rather than hunger. Meganium perfects it further, deploying the scent as a dual-purpose elixir, luring bees and butterfree to its bloom for mutual pollination, while simultaneously dulling the aggression of encroaching carnivores like Ursaring or Scyther. Imagine the scene. A rival beast lunges only to inhale the mist, muscles slackening, eyes glazing as neural receptors flood with serotonin analogues, turning fury to torpor. Studies in Pokémon ecology mirror this to real-world orchids and figs, where floral volatiles disarm herbivores and summon allies, but amplified in these giants to ecosystem scale. In revived herds or forest groves, sweet scent fosters fragile peace, allowing docile natures to endure amid sharper teeth. Amora's emissions, crystalline and cool, blend with frost-kissed air. Meganium's warm and floral, weaving through undergrowth like invisible threads. Both pheromones linger, marking safe havens where young can nurse on secreted nectars or milks. Reproduction tied to these giants' cycles. Eggs laid in scented nests, drawing protective swarms. Disrupt this and chains unravel. Pollinators vanish, fungi go unpicked, predators grow unchecked. Handlers today replicate it synthetically, misting enclosures to ease fossil tensions, watching Tyrantrum slump into drowsy truce beside its gentle kin. These docile giants remind us that true power often hides in restraint. their legacies challenging our assumptions of prehistoric might and verdant grace. But as we trace their scents fading into storm-swept skies, whispers emerge of even stranger behemoths riding thunderheads and lightning veins. Up next, atmospheric anomalies beckons, where the air itself pulses with life you won't believe. While Meganium's nostrils bristle with those fungal antennae, delicately sampling the humid updrafts from the forest canopy. The true architects of the sky demand far more radical solutions to survive where the air thins to a razor's edge and storms rage unchecked. Consider Zapdos, that colossal bird of legend, perched eternally on thunderheads like a sentinel forged from the storm itself. Its feathers aren't mere plumage. They're a network of conductive filaments, each one a living lightning rod, siphoning raw plasma from supercell thunderstorms to fuel a body that thrives on chaos. Picture the scene. A towering cumulonimbus anvil stretches 20 miles wide, its core a churning vortex of hailstones the size of Pokeballs, and winds whipping at 200 miles per hour. Zapdos dives into this maelstrom, wings spread to maximize surface area, its plumage shimmering with iridescent keratin scales embedded with piezoelectric crystals. These crystals generate voltage from mechanical stress alone. Every gust, every hail impact, building charge until the bird becomes a walking capacitor, storing gigajoules of electricity in specialized muscle sacs lined with superconducting membranes. Deep within those sacs, electrolytes slosh like batteries from another world, converting lightning's fury into bioelectric pulses that power flight, metabolism, even reproduction. Scientists speculate Zapdos doesn't just endure supercells, it summons them, releasing pheromones that ionize the air and seed updrafts, turning the atmosphere into its personal forge. Eggs laid in the eye of such tempests hatch amid crackling discharges, imprinting offspring with storm affinity from the first breath. No wonder sightings cluster around hurricane seasons. Zapdos isn't fleeing the lightning, it's harvesting it, a predator of weather itself, leaving scorched ozone trails that pilots report as ghost auroras even on cloudless nights. But survival at those altitudes demands more than storm-chasing prowess. Flying types like Rayquaza confront the invisible killer of the stratosphere, extreme altitude sickness, where oxygen plummets below 5% and barometric pressure drops to a whisper. Human climbers on Everest gasp at 29,000 feet. Rayquaza coils at 60,000 in air so sparse a match wouldn't ignite. How? Specialized hypercapacitant lungs, vast chambers rivaling hot air balloon volumes, lined with alveoli the size of your fist, each packed with hemoglobin analogues that bind oxygen at efficiencies defying physics, up to 98% saturation, even in near vacuum. These lungs aren't static, they're dynamic bellows, inflating with a serpentine undulation that draws in rarefied molecules from miles below, filtering nitrogen through graphene-like membranes to prevent the bends. Rayquaza's trachea branches into fractal networks, maximizing diffusion surfaces equivalent to a football field folded into its frame. During delta streams, those jet-like rivers of air at 200 knots, it hyperventilates in rhythmic pulses, expelling carbon dioxide in explosive bursts that propel it upward like a living rocket. Fossil records hint at ancestral sky serpents evolving this during ancient ozone spikes, when ultraviolet pierced thinner skies, forcing adaptations that turned poison into power. You feel the strain just thinking about it, lungs burning, vision tunneling, yet Rayquaza soars effortless, its scales glistening with a frost of sublimated moisture, guardian of the ozone throne. This atmospheric mastery peaks in enigmas like cast form, the ultimate shapeshifter of the skies whose very cells rewrite themselves in response to barometric whispers and humidity's sigh. No rigid skeleton here, just a protoplasmic lattice, organelles floating in a cytosol that phase changes instantly, lipids crystallizing into icy spikes under sub-zero downdrafts, proteins unfolding into steam vents when thermals boil past boiling point. Imagine a supercell's flank, where pressure swings from sea-level crush to mountaintop void in seconds. Karst forms membrane receptors, voltage-gated ion channels, hypersensitive to pascals, trigger cascades rewriting its proteome mid-flight. One moment, it's a sunny orb, photosynthesizing stray photons. The next, hail-formed crystals refract radar pulses, vanishing from Doppler screens. Biologists puzzle over its nucleus, a mutable organelle shuffling genes, like a deck of cards, activated by hygrometers embedded in every cell wall. Rainy fronts swell it to aqueous blobs, filtering toxins through osmosis. Drought shrivels it to sandy husks that burrow into thunderclouds for moisture. No evolution needed, just instantaneous polymorphism, echoing extremophile microbes in Atacama salts or Antarctic dry valleys, but amplified to macroscopic frenzy. Karst form doesn't adapt to weather, it becomes it. A barometer with a heartbeat, drifting cumulonimbus nurseries, where offspring bud like cloud fractals, each inheriting the parent's last form as survival instinct. These aerial marvels, lightning harvesters, oxygen thieves, weather wraiths, reveal how Pokémon biology pierces the veil of our atmosphere, turning peril into playground. Yet their solitary flights hint at deeper patterns waiting in the wild, alliances forged in the treetops, pecking orders etched in claw marks, the raw dance of dominance and kinship that defines their social worlds. Tune in next for Chapter 12, Behavioral Ecology and Social Hierarchies, where we unravel the hidden codes governing swarm loyalties and alpha rituals that could rewrite everything we know about Pokémon packs. As Rayquaza commands the skies with its unparalleled lung capacity, slicing through thin air where few could survive, you might wonder how Pokémon on the forest floor navigate their own brutal hierarchies. Down here, amid the tangled undergrowth and humming canopies, survival hinges not on solitary might, but on the pulse of collective intelligence, the raw, buzzing symphony of swarms that turns individuals into unstoppable forces. Take the Beedrill colonies, those razor-winged warriors born from the unassuming grubs of Weedle and Kakuna. In the wild, they've been observed forming vast hives deep within ancient oaks, where a single queen dictates the rhythm of thousands. It's not blind obedience, it's a hive mind woven from pheromones, drifting like invisible threads through the humid air. Scouts venture out at dawn, their stingers twitching as they sample the wind for nectar trails or rival scents. One wrong whiff, a trace of intruder venom, and the entire swarm erupts, wings blurring into a golden storm that shreds leaves and flesh alike. Researchers tagging these hives with tiny trackers, much like Yonohara's Pokecology field notes, have clocked response times under 10 seconds, faster than any vertebrate pack. The queen doesn't command with roars, she pulses chemicals through her abdomen, rippling commands that make drones pivot mid-flight, forming living barriers around the hive entrance. Lose a scout, and the hive mourns in silence, reallocating foragers to cover the gap, their collective memory etched in wax combs that store not just honey, but the encoded history of every raid won or lost. Shift your gaze to the Vespican nests, and the complexity deepens into something almost architectural. These combs aren't mere shelters, they're living fortresses, tiered chambers pulsing with the labour of combi drones. The Vespican queen, bloated and regal, anchors the heart. Her body, a chemical factory excreting hormones that cast the swarm, some into builders, gnawing resin into hexagonal perfection, others into sentinels, with abdomens swollen for venom payloads. Observations from coastal thickets reveal how she grooms her elite guard, the Vespa-like workers whose multifaceted eyes scan for threats, while their sisters fan pheromones to maintain the humid equilibrium inside. Disrupt that balance, say, with a clumsy human boot, and the response is surgical. Outer drones sacrifice themselves in explosive swarms, coating invaders in corrosive honey, while inner layers reinforce the Queen's chamber with fresh silk. It's a society where altruism isn't noble. It's etched into their genes, ensuring the Queen's lineage endures through eggs laid in ceaseless cycles, each one a pawn in the grand ecological chessboard. These swarm dynamics don't exist in isolation. They clash daily with the territorial tyrants of the underbrush, like the Mankey and primate colonies that prowl the jungle fringes. Picture a troop of Mankey, fur matted with sweat and berry juice, staking claim to a sun-dappled clearing rich in fruit trees. The alpha primate, its brow furrowed in perpetual scowl, rises on hind legs to deliver the first warning, a guttural huff that echoes like thunder through the vines, fists pounding chest in rhythmic defiance. Wild studies mirror primate troops on Earth, where these displays flood the air with musk, a volatile cocktail that wilts nearby leaves and sends weaker rivals scampering. Intruders, be they rogue beedrill scouts or ambitious young Mankey challengers, trigger the full defense. The colony forms a bristling phalanx, hurling stones with pinpoint fury, while the alpha circles, eyes blazing with calculated rage. One tagged primate troop held a berry grove for months against Ursaring incursions, their warning roars escalating to coordinated flurries of slaps and bites that left challengers battered but alive, establishing boundaries without needless death. What fuels this precision? Play, that deceptively gentle thread running through Pokémon development from hatchling to elder. In Mankey creches, juveniles tussle in mock battles, tiny fists glancing off siblings' hides amid squeals and rolls through the leaf litter. It's no chaos. These bouts sharpen reflexes, teaching the subtle read of an opponent's feint, the perfect angle for a dominance grab. As they mature, play evolves into ritualized combat, full-grown primate locking arms in tests of endurance, grunts sinking like war drums until one yields, bowing low without a drop of blood spilled. Across species, battles serve this non-lethal forge. Beedrill drones spar in aerial dogfights, stingers pulling short to hone venom precision. Vespiquen workers clash mandibles in chamber skirmishes, establishing rank for queenside duties. Even in mixed territories, a wandering primate might challenge a beedrill patrol to a standoff, postures flaring until pheromones and huffs negotiate truce, hierarchies etched anew each dawn. You feel the weight of it in the wild. These aren't games for sport, but the heartbeat of social order, where dominance ensures resource flow, mating rights, and pup survival. A young beedrill that masters the hive's aerial weave rises to forage-led, gorging on prime pollen. A primate victor claims the troop's core sleeping nook, its scent marking territory for seasons. Disruptions like storm-felled hives or poached groves force reshuffles, play intensifying into frenzied bouts that rebuild the ladder overnight. Its behavioural ecology at its rawest, hierarchies as adaptive as any evolution, binding swarms and troops into resilient webs that outlast lone predators like that lofty Rayquaza. Yet beneath these overt displays lurks a subtler arsenal, one that blurs the line between guardian and ghost. In the shadows of these hierarchies, certain Pokémon wield deception as their sharpest stinger, masters of mimicry that turn the tables on swarm and colony alike. What happens when a harmless guise infiltrates a beedrill hive, or a false warning scatters a primate patrol? That's the cunning world we'll uncover next in Mimicry and Deception. While primate colonies thump their chests and unleash guttural roars to claim their turf, not every Pokémon shouts its presence from the treetops. You've got species that whisper through the underbrush, blending into the world around them until it's too late to spot the trap. Take Voltorb, that unassuming sphere rolling silently across forest floors or bobbing in tall grass. At first glance, it's a discarded Pokeball, scuffed red and white, the kind any trainer might overlook after a long day of hikes. But this isn't coincidence. It's a masterpiece of evolutionary mimicry, honed over generations in an arms race against the very humans whose tech it apes. Picture the scene in those humid Kanto woodlands where wild Voltorb first emerged. Early humans fumbling with primitive capture devices left behind prototypes, crude balls of metal and polymer that glinted just so under dappled sunlight. A proto-Voltorb, perhaps a simpler electric-type blob, stumbled upon one, its cellular structure latching onto the shape through some genetic quirk. Over time, natural pressures selected for perfection. The dome perfectly rounded, the white band razor-sharp in contrast, even subtle wear patterns mimicking battle scars. Why? Predators like Pidgeotto or even curious Rattata would paw at what looks like easy loot, only to trigger a static discharge that fried their nerves. Voltorb didn't chase, it waited, disguised as junk. But humans adapted too, their Pokeballs growing sleeker, adding locks and sensors by the 1990s in our timeline. Voltorb lineages raced to match, evolving faint electromagnetic pulses to mimic the ball's idle hum, even replicating the click of a failed capture. In wild populations today, you'll find Voltorb variants with micro scratches that shift like healed wounds, fooling even seasoned rangers. This back and forth echoes real-world Batesian mimicry, where harmless snakes copy coral snakes' warning colours to dodge hawks. Except here, Voltorb turns the tables, its internal battery charging from ambient static until the mimicry pays off in a shocking burst. One wrong touch and that abandoned ball explodes in voltage, leaving scorch marks and a lesson in deception. Deeper in arid Johto Badlands, another imposter thrives. Sudowoodo, the rocky pretender swaying like a brittle tree amid sun-baked scrub. Its branches creak in the wind, bark flaking just enough to pass for drought-stricken wood. But snap one off, and you'll find not sap, but crystalline calcium deposits denser than concrete. This calcified armour isn't for show. It's a desperate bulwark against the riverside water types that prowl these fringes like polywag swarms or predatory quagsire lumbering from seasonal floods. Imagine the evolutionary crunch. Ancient Sudowoodo ancestors. Mobile rock mimics fleeing glacial melts or monsoon surges learn to anchor in place, photosynthesizing faintly through mineral-veined leaves while predators circled. Water types, with their acidic saliva and hydrostatic blasts, shredded softer disguises. Survivors mineralized, pulling silica and carbonates from fossil-rich soils to ossify their limbs. Now, a goldy nip glances off like rain on stone. A water gun shatters against unyielding bark that regenerates via slow mineral uptake from groundwater. Sudowoodo even sways rhythmically, mimicking wind-tossed mesquite, its root-like feet gripping sand to feign lifelessness. Pokeologists note faint seismic tremors when threatened, subtle quakes that mimic root expansion, deterring diggers like Diglett. One study from 1998 observed a Sudowoodo colony enduring a Croconaw raid unscathed, their calcification gleaming wetly post-flood, bodies rigid until the waters receded. Yet Sudowoodo's ruse falters under mimicry's limits. Douse it with real water, and panic sets in, the tree uprooting to flee. This vulnerability hints at the pinnacle of deception lurking in shadowy caves. Ditto, the ultimate shapeshifter, a quivering blob of pink potential. Unlike Voltorb's static shell or Sudowoodo's stony shell game, Ditto rewires itself at the cellular core, its body a soup of undifferentiated stem cells primed for any form. These aren't your garden variety transformers. Ditto's genome floats in perpetual pluripotency, echoing embryonic stem cells in real vertebrates, but amplified to absurdity. Touch a Rhyhorn, and Ditto's cells cascade through gene expression cascades, activin surging, transcription factors flipping like switches, rebuilding musculature, horns, even behavioral tics in minutes. Molecular mimicry goes skin deep. It duplicates pheromones to fool packmates, retinal patterns for avian predators, down to isotopic ratios in feathers matching the original's diet. In lab dissections, ditto tissue under electron microscopes reveals hypermobile organelles, mitochondria reshaping for oxygen demands of a Pidgeot saw or a Snorlax slumber. Wild ditto haunt fringes of ecosystems, scavenging as Shansi nurses, or infiltrating Zubat flocks to pick off stragglers undetected. Their limit? Energy drain, prolonged mimicry taxes that stem cell vat, forcing reversion to blob form under stress, a puff of transformative gas venting excess proteins. Encounters spike near human settlements, ditto aping lost growlithe pups to snag berries from unwary picnickers. Pokebiologists hypothesize ditto as a relic convergent evolution, akin to slime molds aggregating into multicellular hunters or planarian flatworms regenerating whole bodies from snippets. One ditto captured in 1996 Sinnoh wilds held forms of over 50 species sequentially, its nucleus a whirlwind of retroviral snippets scavenging DNA on contact. This cellular chicanery raises chilling questions about Pokémon boundaries. Could ditto seed new lineages, injecting mimic genes into eggs? Field reports whisper of ditto hybrids, aberrant offspring, blurring species lines, thriving where pure mimicry fails. Voltorb's tech trickery, Sudowoodo's stone facade, Ditto's fleshy forge. They all weaponize illusion against a world of sharp eyes and sharper appetites. As deception fades into the twilight of wild habitats, some Pokémon push further, infiltrating the glowing sprawl of human cities, where survival demands bolder disguises still. That's what we'll uncover in Chapter 14, The Urban Adaptation, where streetlights reveal evolutions you never expected amid the concrete jungle. I hope you're as amazed by this as I am. If you want to stay updated on more content like this, make sure to subscribe and join our community of curious minds. Trust me, what's coming next will challenge everything you thought you knew. As human cities sprawled across the landscape, swallowing forests and rivers alike, some Pokémon didn't just survive the encroachment, they thrived within it, turning the chaos of our waste into their cradle. Sudowoodo's rocky disguise might fool water types in the wild, but in the concrete jungles, deception gave way to something far more profound: raw adaptation to the refuse of civilization itself. Consider the alleys behind a bustling factory district at dusk, where the air hangs thick with the metallic tang of rust and the sour rot of discarded chemicals. There, amid overflowing dumpsters and cracked asphalt, Grimer first emerged, not as invaders, but as opportunistic sludge born from the toxic runoff of early industrial spills. These amorphous blobs, little more than living sewage, pulsed with a primordial hunger, breaking down plastics and oils that no natural microbe could touch. Over decades, as cities ballooned, Grimer populations exploded, their gelatinous bodies mutating under constant exposure to pollutants. Enzymes evolved in real time, courtesy of that peculiar Pokémon metamorphosis we call evolution, allowing them to secrete acids that dissolved synthetic polymers while neutralizing heavy metals like lead and mercury. By the time their larger forms, Mook, began lumbering through sewer systems, these poison types had become indispensable. Picture a modern metropolis without them: landfills swelling to bursting, rivers choked with microplastics, the groundwater turning to poison. Mook's porous skin absorbs contaminants like a sponge, converting them into harmless gases vented through bubbling pores that release a faint, acrid mist at night. Biologists monitoring urban ecosystems have clocked Mook colonies processing thousands of tons of waste annually. Their slow, deliberate movements churning through garbage mountains in parks and under bridges. They've even formed symbiotic partnerships with smaller scavengers, excreting nutrient-rich slurry that feeds ratata swarms, closing the loop in this gritty urban food web. What started as a freak accident of pollution has positioned Grimer and Mook as the unsung heroes of decomposition, their oily trails marking the veins of every great city. Yet not all urban dwellers rely on rot for survival. High above those sludge pits, in the neon glow of market stalls and crowded streets, Meowth scratches out a life intertwined with humanity's obsession for wealth. These sleek felines, with their coin-etched foreheads glinting under streetlights, possess an innate compulsion toward anything shiny: coins, jewellery, bottle caps tumbling from tourists' pockets. It's no mere quirk, their biology drives it. Meowth eyes feature specialised retinas that detect metallic sheens across vast distances, a hyper-acute vision tuned for scavenging in low light. They dart through throngs of shoppers, paws snatching lost change with surgical precision, their tails flicking like divining rods toward the next glimmer. This attraction forged a profound symbiosis with human commerce. In sprawling night markets, from Kanto's ports to Johto's trade hubs, Meowth act as unwitting sentinels, alerting vendors to pickpockets by yowling at pilfered goods. In return, merchants toss scraps of fish or poke puffs, fostering colonies that patrol stalls like living security systems. Deeper still, Meowth have infiltrated the underbelly of economies. Feral packs trading pilfered trinkets with street urchins for food. Their hoards buried in alley caches that rival a miser's vault. Evolve one under stress, and Persian emerges, imperious and calculating, often shadowing high rollers in casinos, batting at roulette chips with hypnotic grace. Their purrs vibrate at frequencies that soothe frayed nerves, drawing crowds and tips alike. Humanity's glittering commerce isn't just tolerated by Meowth, it's their lifeblood, a dance where feline instinct meets capitalist gleam, ensuring both species prosper amid the urban roar. But humanity's ingenuity pushed adaptation further, blurring the line between organic life and the digital realm. Deep in research labs during the late 20th century, scientists achieved the impossible. Porygon, the first Pokémon synthesized not from egg or evolution, but from pure code. Imagine sterile server rooms humming with fans, screens flickering as algorithms mimicked cellular division. Programmers at Sylph Coast drew from viral replication patterns, encoding behaviors into binary, movement as particle simulations, attacks as data bursts. Uploaded into a prototype conversion chamber, this digital blueprint materialized as a squat, polygonal, duck-like form, its body a lattice of glowing pixels that solidified into pliable, rubbery flesh. Porygon didn't just exist, it adapted. Its core processor, a quantum-like neural net, allowed instantaneous evolution via software patches. Porygon 2 refined its form for efficiency, gliding through networks as easily as air. In urban wilds, these digital natives patrol data centers, debugging corrupted files with electric pulses that fry malware, their eyes scanning code streams like predators eyeing prey. Yet glitches reveal their fragility. Overclocked systems spawn rogue variants, phasing through walls in bursts of static, a reminder that even synthetic life hungers for stability. Porygon's birth marked humanity's foothold in Pokémon creation, proving biology could spring from silicon, forever altering the urban evolutionary tapestry. These urban pioneers, Grimer dissolving our filth, Meowth chasing our fortunes, Porygon bridging code and cell, reveal how Pokémon don't merely tolerate cities, they redefine them. Swarms of Voltorb still mimic discarded tech in junkyards, echoing that arms race we explored last, but now alongside muck sludge rivers flowing into storm drains. Together, they form resilient ecosystems where human excess fuels Pokémon vitality, and vice versa. As we leave the neon-lit streets behind, prepare yourself for Chapter 15, Extreme Habitats and Alien Origins, where we'll uncover Pokémon that defy earthly physics in realms of fire, void, and beyond. Worlds that will stretch your understanding of life itself to the breaking point. While Meowth prowls neon-lit alleys for the glint of discarded coins, and Mook silently breaks down the chemical sludge of overflowing sewers, a handful of Pokémon have pushed far beyond Earth's forgiving crust. They've claimed homes in the airless void of the moon's surface, the radiation-scorched emptiness between stars, or realms where gravity twists into knots and physics unravels like frayed thread. Consider Clefairy, that diminutive pink-furred wanderer often glimpsed under starlit skies. Its body, compact and buoyant, betrays no earthly origin. Delicate wings unfold from its back, not for flight in our atmosphere, but to glide across lunar regolith in gravity 1/6 as strong as ours. Those wide, unblinking eyes, rimmed in black like cosmic ink, absorb the faintest starlight, filtering ultraviolet rays that would blind a human in seconds. Clefairy's skin, soft yet resilient, secretes a thin, silvery film, much like the extremophiles clinging to Antarctic ice, that seals pores against micrometeorite impacts and the moon's relentless temperature swings, from scorching days of 230 degrees Fahrenheit to nights plunging below -280. Lunar samples, brought back by human probes, teem with hardy microbes that thrive in vacuum and radiation, repairing DNA on the fly. Clefairy takes this further. Its metabolism runs on moonstones, crystalline chunks rich in rare minerals, which it ingests like candy, converting their energy into bursts of levitation. Witnesses in remote observatories have clocked Clefairy populations spiking during meteor showers, drawn to fresh fallen rocks that mimic their ancestral diet. No wonder folklore paints them as moon fairies. They're refugees from a barren world, their songs faint ultrasonic trills that echo through vacuum via psychic vibrations, calling kin across craters pocked with ancient footprints. But if Clefairy whispers of the moon's quiet desolation, Deoxys screams of the deep black between galaxies. This crystalline enigma, with its pulsing red core and tentacles that morph like living origami, defies classification as animal or virus. Genetic scans, if such a thing were possible, would reveal a helix warped by cosmic rays, a shapeshifter born in the heart of a supernova's afterglow. Deoxys arrives via meteorites, slamming into Earth like arrows from the void, its form compressing into a defensive streak during re-entry. Heat shield of pure psychic force. Once landed, it reconfigures, arms elongating into blades for attack, or coiling into sensory whips that detect electromagnetic storms light years away. Its core throbs with otherworldly energy, powering regeneration that knits severed limbs in moments, fueled by quantum entanglement. Particles linked across distances no earthly biology can fathom. Deoxys doesn't breathe oxygen, it harvests radiation. Protons streaming from solar winds, converting them into psychic pulses that warp local gravity fields. Imagine encountering one in a high-altitude crash site, the air humming with static. Your shadow fracturing as it probes your mind, assessing threats from a lifetime orbiting gas giants, where pressures crush diamonds. These cosmic colonists hint at Pokémon origins scattered across the solar system, seeding life on barren worlds before hitchhiking home. Yet even they pale against Magcargo, the living furnace masquerading as a snail. This molten behemoth carries an internal inferno hotter than the sun's photosphere, 18,000 degrees Fahrenheit, its body a sluggish river of magma, encased in a brittle obsidian shell. One touch and you'd flash to vapour, but Magcargo ambles through volcanic fields unscathed, leaving trails of cooled basalt that harden into new rock. How? Its physiology is a masterpiece of thermal isolation. The outer carapace, veined with supercooled crystals, akin to those in deep-sea vents, reflects 99% of its own radiant heat inward, like a space shuttle tile in reverse. Beneath lies a gel-like mantle, infused with exotic minerals, perhaps perovskite analogues from Earth's mantle that phase change at precise thresholds, absorbing excess energy as latent heat without boiling away. Mag cargo doesn't metabolize food traditionally. It fuses heavy elements in its core, nuclear reactions simmering at controlled yields, expelling helium through porous vents as faint, glowing exhaust. Surrounding air shimmers, but never ignites because the beast regulates output meticulously. During rest, heat sinks into subsurface aquifers, warming geothermal springs for miles. In battle, it flares, spewing lava globs that solidify mid-air into glassy projectiles. Volcanologists puzzle over sites where mag cargo nests, ground sterilized yet fertile afterward, enriched by trace metals from its sweat. This isn't fire Pokémon bravado, it's survival engineering, echoing extremophiles in Yellowstone's cauldrons that rebuild proteins amid boiling acid, push boundaries further into habitats that shred reality itself. The distortion world, Giratina's fractured domain, defies Euclidean space. Platforms float untethered, up is down, time loops in eddies. Pokémon adapted here boast physiologies that treat chaos as cradle. Giratina's golden armor, segmented like a dragonfly's exoskeleton, phases through dimensions via membrane pores that dilate with willpower, slipping between brains like a fish through kelp. Its kin, like Spiritomb, a vortex of 99 souls bound in a keystone, thrive on entropy. Their gaseous forms lack solid organs, instead circulating plasmic energy that feeds on dimensional rifts, mending probabilistic tears in their essence. Bronzong, hovering bells of bronze, resonate at frequencies that stabilize local gravity wells, their hollow cores humming subharmonics to navigate anti-physics mazes. These beings sense not light or sound, but curvature, the warp of space-time itself, through piezoelectric crystals embedded in flesh that convert gravitational waves into neural sparks. In the distortion world, evolution favors the malleable. Bodies elongate or invert without harm, metabolisms drawing from dark energy gradients, leaking between realms. Escapees into our world bear scars, erratic behaviors, shadows that don't align with light sources. Palkia and Dialga, siblings of distortion, warp matter and time respectively, their scales rippling with pocket singularities that store mass in higher dimensions, explaining their colossal sizes without gravitational collapse. These extreme dwellers, Clefairy moon dancing in silence, Deoxys reshaping from stellar dust, Magcargo's nuclear heart, dimension phantoms of the distortion world, reveal Pokémon as pioneers of the impossible. They've endured where humans dare only probes, their biology a testament to life's audacity, beyond our skies or laws. As we ponder these alien marvels thriving in voids and vortices, questions arise about our role in coaxing them earthward, especially the long dormant ones we've yanked from stone. That moral tangle unfolds next in Chapter 16, the ethics of revival and domestication. While Magcargo's molten core endures infernos that would melt steel, and Clefairy's ethereal forms hint at stardust origins beyond our skies, humanity's boldest act of playing God unfolded in underground labs, where dust from ancient seabeds stirred to life creatures that hadn't soared or rampaged for 65 million years. Aerodactyl, that jagged-winged terror with a beak forged for ripping flesh from the sky's largest prey, burst from its fossil prison, not as a museum relic, but a living storm ready to reclaim the winds. Picture those first revival flights over the Johto coasts in the early 2000s, scientists watching in awe as leathery wings spanned 20 feet, slicing through sea spray with a screech that echoed prehistoric thunder. But awe turned to alarm fast. These weren't gentle giants. Aerodactyl hunted like the apex reaper it evolved to be, plummeting on schools of wing gull and palliper mid-migration, shattering flocks that had patterned the skies for generations. Modern ecosystems, already strained by human sprawl and climate shifts, buckled under the onslaught. Prey populations like Tylo and Starly plummeted in revived zones. Their nesting cliffs stripped bare, forcing ripple effects down the chain. Fewer insects for caterpie, overgrown berries, uneaten by Staravia young. Researchers tagged the first batches, tracking how a single aerodactyl pair could decimate local flying-type densities by 30% in a single breeding season. Their hyper-carnivorous appetites ignoring the smaller, faster morsels of today for the massive hauls they remembered from the Cretaceous. Worse still, these revived predators didn't just hunt, they dominated. Cabotops scuttled into coastal reefs, their scythe arms eviscerating corfish and clample that had no evolutionary defense against such ancient blades. Armaldo prowled shallow seas, unearthing crabby burrows and upending sediment clouds that choked filter feeders like shallows for miles. In the skies, Aerodactyl engaged in brutal turf wars with resident Pidgeot and Fiaro, driving them to higher, harsher altitudes, where oxygen thinned and eggs froze in exposed nests. Ecologists dubbed it the fossil cascade, a domino fall where top predators vacuumed resources, starving mid-tier hunters and bloating scavenger populations like Murkrow into plague-like swarms. By the mid-2000s, release protocols tightened. Some regions mandated tracking collars, but wild escapes turned coastal towns into no-fly zones, fishermen hauling nets empty of the fish Pokémon once guarded. Yet the fallout deepened in subtler fractures, far from those dramatic clashes. Enter the Pokeball, that deceptively simple red and white orb, humanity's bridge between wild freedom and captive command. Trainers scoop up migratory marvels like Pidgeot mid-flight or Noctowl on nocturnal hunts, only to release them weeks or months later in distant parks or routes. What does that do to the ancient rhythms etched into their biology? Take the great autumn migrations of southwestern Hoenn, flocks of Swablu and Altaria threading cloud rivers from mountain peaks to coastal blooms, timed precisely to monsoon winds and berry riperings. A single capture disrupts the V formation's acoustic signals. The low-frequency calls that guide stragglers home, released off course, that Swablu might join a rival flock, diluting bloodlines and weakening hybrid vigor. Mating rituals suffer even more profoundly. Consider the luminous dances of love-disc pairs in lowland reefs, synchronized bioluminescent pulses that align spawning with lunar tides, drawing nutrients from plankton blooms. Snagged by a passing trainer for a beachside contest, then dumped back post-victory, the fish arrives weeks late, its glow out of sync, suitors scattered, eggs laid in barren shallows, where currents whisk them to predators. Studies from the Pokecology field teams, mirroring real-world bird banding, reveal capture-release cycles, compressing seasonal breeders like Fiaro into erratic clutches. Females ovulate prematurely from stress hormones, yielding frail chicks unfit for wild gauntlets. For long-haul wanderers like Fiaro or Tropius herds trudging savannas, repeated balling fractures, family pods, calves separated from matriarchs lose learned migration maps, wandering into deserts where they perish from dehydration. It's a quiet domestication by attrition, Pokeballs rewriting migratory maps into fragmented puzzles, turning epic journeys into trainer-timed pit stops. This interference sparks the fiercest debates in Pokemon ethics circles. Are these beings pets, partners, or mere biological tools? On one side, the pet advocates point to species like Eevee or Lillipup, bred for loyalty over generations, their tails wagging at human scent like domesticated wolves trailing campfires. Revival fossils like Armora embody this. Docile saurians revived around 2009 content to graze seagrasses under human watch, their gentle bleats more barnyard than battlefield. Handlers argue we've tamed them ethically, providing veterinary care absent in wild perils, turning potential pests into cherished companions whose milk or wool sustains rural economies. Partners, though, paint a collaborative canvas. Battles aren't cruelty, they're ritualized hunts, echoing wolf packs, testing strength, or meerkat sentries, drilling defenses. Trainers and Pokémon co-evolve, Raichu storing static from shared storms, Lucario syncing aura with a human's intent, forging bonds deeper than ownership. Fossil revivers like Tyrantrum, unleashed in 2013, thrive in this dynamic, their scavenger brains bonding over fresh kills shared post-spar, filling niches left empty since the meteor fall. But the tool view cuts darkest whispered in corporate boardrooms where Kranados herds power quarry drills, their headbutts pulverizing stone for rare ores, or Voltorb farms generate grid electricity from self-discharges. Critics decry it as exploitation, Pokémon reduced to livestock, their evolutions triggered by vitamin cocktails for maximum yield, eggs harvested like factory chickens. Revival ethics amplify this. Should we resurrect Aerodactyl only to collar it as an air patrol drone, or Rampardos as living bulldozers? Protests erupted in Unova after 2013, banners reading "Fossils aren't slaves," as escaped Tyrantrum ravaged farmlands, blurring wild rights with human utility. These lines blur in practice, of course. Your childhood Pidgeot might soar free by day, curling loyal at your tent by night, partner in gym duels yet tool for scouting lost trails. Revival forces the question sharper. Amora's placid eyes gaze from enclosures, but unleash it unchecked, an ecosystem's hemorrhage. Domestication's ethic hinges on consent we can't voice, on interventions that heal some wounds while carving others. As these ancient echoes reshape our world, whispers grow of what's coming next in Pokémon biology, transformations that could redefine life itself. Stay with me through Chapter 17, The Future of Pokémon Biology, where we'll uncover visions that might just rewrite the code of existence. As we've seen with the chaotic reintroduction of Aerodactyl, ripping ancient predators from their stone tombs doesn't just stir up old skies, it reshapes the skies of tomorrow. Those capture and release cycles from Pokeballs, meant to mimic a trainer's fleeting bond, have already scrambled migration routes for species like Pidgeot and Pharaoh, turning seasonal flights into erratic loops around human sprawl. Wild populations mate out of sync now, their eggs hatching under streetlights instead of starlit canopies. And this meddling hints at something bigger. Pokémon biology isn't standing still, it's accelerating, pushed by our warming world and endless expansion. Consider the poles where ice shelves crack like brittle eggshells under relentless heat. Alolan Vulpix, those frosted foxes born from isolated tundras, once thrived on glacial streams teeming with vanillite shards. But as oceans rise and permafrost thaws, their ice types weaken, fur matting in unseasonal rains. Biologists in the field whisper of a shift already underway, pups emerging with sleeker coats, hints of water typing bleeding into their veins, adapting to flooded dens. This isn't the familiar glow of evolution at level 16. It's a slower burn, Darwinian in flavour, where climate forces survivors to mutate or fade. Fly south to arid wastelands, and you'll find Galarian Corsola bleaching white. Their coral branches crumbling not from age, but from overheated seas starved of plankton. The few that endure sprout tougher, rockier polyps, scavenging minerals from polluted runoff, proto-ground variants edging toward permanence. Human footprints accelerate it all. Our megacities bleed concrete veins across forests, fragmenting habitats into isolated pockets. Take the Sinnoh Highlands, where wild Lucario once roamed vast packs, aura senses attuned to mountain echoes. Now, highways carve them apart, leaving clans on either side of asphalt rivers. Eastern groups, battered by industrial smog, develop thicker hides laced with steel resilience, while Western ones near logging scars lean into ghostly evasions, phasing through fallen timber. Over generations, these divides deepen. Eggs from crossbreed attempts yield frail hybrids, sterile like mules. Isolation breeds divergence, and what starts as regional variants could solidify into full species splits. Imagine Hishuian growlithe splitting further, coastal packs turning electric to harness tidal surges, inland ones burrowing as pure ground, no longer compatible, no tradestone reversal possible. Prolonged separation, you see, rewires DNA at its core, turning Pokémon flavor text into evolutionary fact. We've watched it tease at the edges already. The white-streaked Galarian Zigzagoon evolved from Hoenn invasives gorging on urban scraps. Now Linuan variants sprint through European alleys, with darker, oil-slicked fur to blend with night traffic. Dark typing etch deeper each litter. In tropical sprawl, where palm oil plantations swallow rainforests, rowlet lines splinter. Some balloon into bloated Decidue with poison barbs to fend off pesticide clouds, others shrink to agile, flying purists navigating canopy gaps. Climate models predict mass migrations, flocks of toucan fleeing droughts, only to clash with locals, sparking hybrid zones that either forge new forms or collapse into extinction events. Pokémon biology, once a playground of stones and trades, now grapples with our carbon shadows, birthing variants that might outpace our Pokédex entirely. And then there's the human hand, not just paving paths, but rewriting code. The shadow of Mewtwo looms largest here, that psychic colossus cloned from Mew's essence in some forgotten lab, a testament to what happens when we crack the genome wide open. Its creators spliced viral vectors into embryonic cells, amplifying psychic potential until cells screamed with raw power, muscles hypertrophied, brain lobes ballooned like overripe berries. But the fallout? Unstable tempers, rogue clones rampaging through Kanto wilds, interbreeding with wild Mew lines to seed latent psychic traits in Abra evolutions. Today, Fringe Labs chase that high, engineering perfect companions, fire types fused with solar panels for endless flamethrowers, drawing from Heliolisk's real photosynthetic tricks, but cranked to God mode. They harvest Bulbasaur bulbs for chlorophyll boosters, inject Rampardo's fossils with growth hormones to resurrect titanic herds, ethical lines blurring as profit calls. Yet playing God extracts a toll. Mewtwo's legacy echoes in the clone drift, where engineered Pokémon spawn warped offspring, psychic types with brittle bones from rushed calcium overrides, water types bloating with synthetic gills that clog in salty bays. Underground breeders push boundaries further, cross-pollinating Deoxys strains with Clefairy meteor genes for space-hardy explorers. But leaks unleash invasive horrors, hybrids devouring native swarms, disrupting food webs like Grimer on steroids. Regulators scramble, but black market gene drives spread silently, turning regional variants into designer nightmares. Picture a world where your neighborhood Pidgepack hides Mewtwo-tainted alphas, auras flaring to dominate skies, or ocean trenches birthing Kyogre derivatives bioluminescent enough to eclipse stars, luring fleets to doom. The dangers compound, antibiotic resistance jumps species via shared eggs, and chimeric viruses leap from lab vats to wild vectors, echoing real pandemics, but with Pokémon ferocity. These genetic frontiers don't just risk monsters, they redefine wild purity. Fossil revivals, once marvels, now serve as gene banks, scientists splicing Amora docility into Tyrantrum lines for tame guardians, but aggression alleles rebel, birthing rampaging herds that trample farmlands. In response to our sprawl, labs craft urban adapters, Mook variants programmed to devour plastics. Grimer sludge infused with bacterial cocktails for super decomposition. Success stories dazzle. Electric types wired into grids, harvesting storm energy like Zapdos proxies, but each tweak invites cascades. A single escaped prototype could ignite evolutionary arms races, wild populations mutating countermeasures, variants hardening into species walls faster than we can catalogue. As climates shift and our tinkering deepens, Pokémon biology hurtles toward uncharted forms, where today's variants harden into tomorrow's genera, isolation, and engineering forging a new Pokédex beyond recognition. But what of the rhythms that underpin it all? The hidden pulse binding birth to decay across eons? That's the mystery we'll unravel next in Chapter 18, the eternal cycle. As those regional variants carve out their niches amid rising seas and scorched earth, they don't splinter the world apart. They bind it closer, threading every Pokémon lineage into one vast, pulsing food web that spans oceans, skies, and shadowed forests. Picture the sun-dappled leaves of a Bulbasaur colony, their bulbous backs swelling with captured light, chlorophyll humming through veins like a quiet symphony. These grass types stand as the foundation, photosynthesizing sugars from berries and soil, their roots sipping minerals that once armored ancient rock Pokémon eons ago. From there, the chain uncoils with deliberate grace. Voracious bug types like Paras swarm the undergrowth, mandibles slicing into fungal blooms on Meganium's neck, trading spores for strength in a parasitic dance as old as the earth itself. Those same Paras might fall to the fiery raids of Typhlosion, its badger-like snout scorching comb beehives, lapping honey wax that fuels its internal blaze, a fire type reaping the labours of insect industriousness, only to leave charred remnants for Grimer's sludge to dissolve in urban gutters. You feel the current pull you deeper into rivers where Barboach wriggles through silt, its barbels tasting vibrations from above, oblivious to the Tinamo schools flickering like living lightning, their lamprey mouths latching onto softer prey in a water-electric tangle. Gyarados erupts from these shallows as the unchained fury, serpentine coils snapping up schools of Lovedisk, their silver-pink bodies scattering like confetti in the foam. Yet even this apex temper finds balance, for Jellicent's ghostly bells drift in the estuaries, ensnaring weakened survivors with bioluminescent lures borrowed from deep-sea jellyfish kin. High above, the skies weave their own strands. Zapdos perches on thunderheads, wings harvesting storm electricity to sustain its colossal frame, occasionally diving for frillish swarms that rise on tidal breaths. These electric legends rarely hunger alone. Their leavings, singed feathers rich in rare ions, fertilize mountain meadows where Aerodactyl's revived kin soar, beaked shadows reclaiming skies once theirs, snatching fossil peers like rampardos that lumber below, grinding tough ferns in cheek-padded jaws. And the fossils themselves? They don't merely resurrect, they slot back into grooves worn smooth by time. Tyrantrum's olfactory bulbs twitch at the scent of scavenging meat, filling voids left by vanished predators, while Amora's gentle amble through aurora-lit plains invites symbiotic grazers, its docility a beacon in a web scarred by human revivals. Rock-type shells, mineral-hardened over millennia, crumble eventually into soils that nourish the very Bulbasaur bulbs that started our circle, devoured by Paras, burned by Typhlosion, and so on. Each type, from ethereal ghost wisps haunting prey's final fears, to steel behemoths crunching ore veins for lithotrophic feasts, links inexorably. Even the outliers pulse within this tapestry. Heliolisk unfurls solar sails in arid wastes, converting light much like its grass cousins, only to be stalked by Flygon's desert wings, ground dragons that burrow for seismic prey. Deoxys shifts forms in cosmic voids, perhaps seeding eggs that drift to earthly nests. while Clefairy's lunar migrations dust highlands with meteor-rich guano, sparking evolutions in isolated variants. No type stands solitary. Electric jolts power synthetic mook strains in polluted bays. Fire forges paths through ice barrens like Abomasnow, whose avalanches bury and rebirth microbial ghost undercurrents. This global food web thrives on such loops, where predation sparks adaptation, symbiosis blurs boundaries, and decay feeds rebirth. Berries drop from Meganium's petals, luring Raichu from burrows to hoard and spark. Their cheeks pouching charges, stolen from Electros eels that once blood-fed, like sea lampreys in forgotten rivers. Kyogre's oceanic swells redistribute nutrients worldwide. Tentacruel's tentacles filtering plankton that balloons into Whiskash quakes, rippling back to shorelines where Sudowoodo's calcified limbs mimic fallen timber, fooling water hunters until the cycle claims it anew. Through it all runs the profound mystery of the pocket monster, the enigma of creatures who defy kingdoms, laying eggs from electric loins or rocky husks, suckling young with milk from monotreme glands, evolving not by blind chance but willful metamorphosis, reversible as dawn. How do they encompass fish that lure with dorsal glows, mammals that brew fire from hive raids, plants that bloom into warriors? Fossil revivals whisper of ancestries etched in Muse blueprint, regional shifts proving life's unyielding forge. Yet this mystery testifies not to fragility, but to resilience incarnate. In a world of human sprawl and climate tempests, Pokémon endure through interconnection. Predators tempering plagues, decomposers cleansing scars, producers reclaiming ash. Variants may diverge, but the web holds, stretching across dimensions, habitats and epochs, a testament that life, in all its wild diversity, persists by entwining every thread. Drift now with the quiet rhythms of the wild, waves lapping at Kyogre's distant silhouette, Bulbasaur leaves rustling under starlight, Rampardo's low grunts echoing in canyon twilight, frillish bells toll softly in the mist, Typhlosion's embers flicker like fireflies against the night, Barboach sifting silt in eternal patience. The cycle turns unbroken, inviting you to rest within its gentle pulse. What did you think of this journey? I'd love to hear your thoughts in the comments below. If this changed your perspective or taught you something new, consider subscribing for more mind-expanding content. And if you know someone who would find this as fascinating as you did, share it with them. These are the kind of conversations that matter.